What would it feel like to dive into an ocean that existed 7 to 170 million years ago? A sea ruled not by fish, but by giants. Curl up in your blanket, turn down the lights, and imagine this. You're drifting through the warm green-blue waters of the Jurassic. The year is somewhere between 20 and 14 and 45 million years before the present. Above, continents are still moving, slow as dreams. Below, the ocean is alive, teeming, glowing, roaring in silence. This wasn't a peaceful sea. It was a battlefield wrapped in beauty. The food chain here was no gentle circle. It was a storm of teeth and instinct. Every creature, from the tiniest plankton to the largest predator, played its role in a relentless dance of survival. Imagine the silence just before the strike, the flash of motion, the bloom of bubbles where once there was life. And yet, there was wonder. Coral gardens stretched across shallow shelves, hosting creatures that shimmered with colors no human eye will ever see again. Reefs buzzed with life, and strange shapes drifted in the dim light, creatures that seemed like experiments from nature's imagination. It was a world both familiar and alien. The sunlight danced across rippling waves, but what swam beneath would make any diver's heart race. Long-necked Pliosaurs gliding like dragons through misty depths, Ichthyosaurs slicing through schools of fish like silver torpedoes, and ammonites, those coiled-shelled cousins of modern squid, spiraling through the currents like living jewels. The Jurassic Ocean was a forgotten kingdom, a place of mystery, of monsters, of beginnings. So much of it is lost now, buried beneath stone, locked in fossils, or sleeping in the deep. But if we could return, if we could sink beneath those prehistoric waves, what stories would the ocean tell us? So before you drift off tonight, take a deep breath and imagine descending through those ancient waters. Watch the sunlight fade. Feel the weight of time pressing close. Somewhere in that darkness, something stirs, a shadow, a ripple, a glimpse of the world before ours. Would it whisper of creatures too strange to name, of ancient tides that shaped the very world we walk upon? Or would it simply hum, as it always has, with the quiet pulse of life finding its way? If this journey through deep time stirs your curiosity, share your thoughts below. Tap like, subscribe, and let's keep diving into history, into mystery, into the blue heart of the Jurassic. The geological setting, Pliosaurs and Tethys, oceans of the Jurassic Earth. Imagine the world not as the blue and green marble we know today, but as one vast supercontinent adrift on an endless sea. It is the Jurassic, around 1990 million years ago, and Earth's map would have looked like something drawn in a fever dream, a single colossal landmass, Pangaea wrapped on all sides by the greatest ocean that has ever existed. Its name was Pliosaurs, meaning the all-sea, and it was exactly that. A planetary moat, wide beyond comprehension, shimmering beneath a younger sun. But before we dive into the newborn Tethys, let us drift across the Pliosaurs, that ancient titan. If the modern Pacific seems enormous, Pliosaurs would have dwarfed it. It stretched unbroken around the globe, an ocean so large that entire weather systems, if we could have seen them from space, would have looked like brushstrokes across a blue infinity. There was no boundary, no opposite shore to swim toward, no sense of scale, only the slow roll of waves born from winds that had circled the planet unimpeded. Beneath the surface, the Earth was alive and restless. The ocean floor was not the quiet abyss we imagine today, but a battlefield of stone and fire. Mid-ocean ridges wound through the deep, like glowing scars, places where the crust tore itself apart, and magma surged up from below, hardening into new seafloor. These submarine ridges were the arteries of Pliosaurs, carrying heat and minerals through its vast body. Around them, hydrothermal vents spewed clouds of dark, mineral-rich water, chimneys of smoke in the cold blackness, feeding entire ecosystems of ancient microbes that clung to the rocks like whispers of future life. To the west, waves crashed endlessly against Pangaea's cliffs, their sounds swallowed by the immensity of the open ocean. To the east, something was stirring, a line of weakness, a long, slow tear in the crust of the earth. There, the first outlines of a new ocean were forming, a slender seaway that would someday become famous, the Tethys Ocean. It began modestly, as most great things do, not with a bang but with a fissure, a line of molten rock pushing its way between drifting plates, opening a wound that filled with water, light and life. Panthalassa's floor was a mosaic of new and old crust, ceaselessly recycled. In one era it birthed new seabed, in the next it devoured it, pulling it down into the mantle through deep trenches where one plate slid beneath another. These trenches were the graveyards of the ocean floor, where ancient basalt disappeared into the planet's molten interior, reborn in time as fresh volcanic rock. From above, none of this was visible. The sea simply shimmered, a calm surface hiding worlds of upheaval. In some places, the volcanic activity grew intense enough to build sire mounts, great underwater mountains that rose like the spines of sleeping giants. Over time, the tops of some sire mounts broke through the surface, forming islands that barely lasted a geological moment before sinking again beneath their own weight. Others became atolls, rings of coral that clung to the edges of vanished volcanoes. These were among the earliest coral structures of the Mesozoic world, fragile fortresses of calcium and color rising from a foundation of fire. And then along the eastern edge of Pangaea, something remarkable happened. The great landmass began to split. It did so slowly, almost politely, as if unsure whether to commit. But beneath the politeness, molten forces were at work. Magma welled up through fractures in the crust, pushing Africa and Eurasia one way, North and South America the other. As the rift widened, seawater poured in, filling the gaps, and thus began the story of Tethys, the ocean between worlds. Those shallow shelves also became laboratories of stone and life. Coral reefs, primitive by today's standards but tenacious, began to take hold on the edges of volcanic islands and continental slopes. The corals, along with sponge-like organisms and algae, built vast irregular structures that gleamed beneath the clear water. Early reefs were not the lush jungles of color we imagine now. They were more like stony fortresses, rough and uneven. The first attempts by living things to carve permanence into an unstable world, yet their work would last millions of years, forming limestone layers that today rise high above sea level in mountains that once were seabeds. The shallow waters near the rifting continents were rich with geological drama. As magma rose from below, it hardened into new crust, first black basalt, then layers of sediment carried by rivers from Pangaea's coasts. Over millions of years, these sediments compacted into limestone and shale, the building blocks of the future Mediterranean, the Alps and the Himalayas. But in the Jurassic, they were simply the seafloor of a restless, glowing world. If Panthalassa was the ancient emperor of the seas, Tethys was the delicate, mischievous heir, a younger, narrower body of water that would one day shape continents, species, and the history of the Earth itself. Tethys wasn't vast and featureless like its parent ocean. It was complex, filled with contrasts, broad, sunlit shelves and deep-shadowed basins, shallow lagoons where light danced through turquoise water, and narrow trenches where darkness gathered like ink. The deeper parts of Tethys were another story. There the crust was thinner, stretched by the pulling plates, and the weight of water pressed down like a hand on glass. In these abyssal plains, sediments drifted down in slow rain, microscopic shells, volcanic dust, and mineral flakes settling one by one into layers. Every grain recorded a moment, a pulse of the ocean's heart, and when earthquakes struck along the continental margins, great underwater landslides, turbidity currents rushed down the slopes, stirring the quiet depths into chaos. Over time, these events built the flysch deposits that geologists would later find, tilted and folded, high in mountain ranges, formed when continents collided once more. But let's return to the imagery of the surface, the meeting place between water and sky. Picture yourself drifting above this ancient seaway. Beneath you the seafloor is alive with activity. Black smokers venting, pillow lavas cooling, corals anchoring themselves to new rock. Above, light refracts through rolling waves, and occasionally the surface trembles as underwater volcanoes erupt, sending plumes of steam into the air. The newborn Tethys breathes in fire and exhales islands. As the rifting continued, the seaway widened. What began as a narrow crack became a deep and navigable ocean, bordered by the growing continents that would one day form Eurasia to the north and Gondwana to the south. Between them, Island arcs rose like stepping stones, chains of volcanoes marking where the oceanic crust slid beneath continental plates. These arcs were restless, reshaping themselves as tectonic forces shifted. From above, they might have looked like strings of jewels scattered across a sapphire plain. In Panthalassa, the story was more cyclic, almost meditative. As the Tethys expanded and reshaped the Eastern Hemisphere, the Great Western Ocean continued its eternal rhythm of creation and destruction. Mid-ocean ridges snaked across its depths like glowing veins, continuously birthing new crust that spread outward until it met the edge of Pangaea. There the heavy oceanic plate would bend downward, sliding beneath the continent in deep trenches where earthquakes rumbled and molten rock simmered. These subduction zones fueled the rise of volcanic arcs along Pangaea's rim, vast chains of underwater volcanoes that occasionally breached the surface to form islands, only to vanish again in the geological blink of an eye. It is humbling to realize that much of modern geology owes its existence to these vanished oceans. The Alps, the Himalayas, the Zagros, many of Earth's greatest mountain chains were once sediments at the bottom of Tethys. Each layer of limestone, each fossilized coral, each folded ridge tells a tale of the ocean's restless heartbeat. Tethys became a crossroads. Over the next tens of millions of years, as continents continued to drift apart, its waters would connect the western Panthalassan realm to new, smaller oceans forming in the east. Marine life, ammonites, belemnites, and early marine reptiles migrated freely across its basins, but the rocks tell a quieter story of constant motion beneath their feet, of subduction zones consuming oceanic crust, of mountains rising from the sea only to erode again, their minerals washing back into the same waters that birthed them. Panthalassa's abyssal plains were not lifeless deserts, but archives of time. Each new layer of sediment captured a story of shifting continents, wandering magnetic poles, and silent upheavals. Beneath miles of water, the seafloor slowly aged, moving away from the hot mid-ocean ridges toward cooler, darker depths. There it grew denser and heavier until gravity drew it downward, back into the mantle. The life of an ocean floor was circular, poetic in its destruction. The earth built, erased and built again, over and over, as if practicing the art of impermanence. Meanwhile, Tethys grew confident. What began as a narrow crack now stretched from the Proto-Atlantic in the west to the vast realms of what would someday be Asia in the east. It was a place of contrast, where continents drifted apart, but also where new ones would eventually collide. In its shallow arms, reefs expanded, cradling diverse life. In its deeper basins, volcanic sediments accumulated, rich in minerals that would one day become treasure troves for human civilization. The geology of Tethys was a kind of music, slow, rumbling, but full of rhythm. Each tectonic pulse, each plume of magma, each slow deposition of sediment was a note in a symphony billions of years long. If the Earth could have listened to itself, it might have heard the sound of continents splitting, the hiss of underwater eruptions, the slow percussion of waves beating against newborn shores. Even the rocks of future Europe and Asia bear the fingerprints of this music. The limestone cliffs of the Mediterranean, the marble of the Greek islands, the folded strata of the Himalayas, all were once part of the Tethys seafloor. When India began its long, slow collision with Asia tens of millions of years later, it closed the last chapters of Tethys, pushing those ancient seabeds upward into sky-high ranges. But that was far ahead. In the Jurassic, Tethys was still young, vibrant, full of potential. If you were to stand somehow on a volcanic island along its edge, say a newly risen ridge somewhere between the future Africa and Eurasia, you might see steam rising where lava met water, hear the hiss of cooling stone, feel the tremor of the crust beneath your feet. The air would smell faintly of sulfur and salt. Beneath the waves, coral larvae would already be settling on the new rock, sensing the minerals beginning their quiet construction. In a few thousand years, the black stone would turn white with carbonate deposit. In a few million, that reef would be a thriving ecosystem. In a few 100 million, it would be limestone folded into mountains. Time in this world was the patient architect. And what of humor amid all this grandeur? Well, if you think about it, the Earth was something of a cosmic comedian. Here it was, busy tearing itself apart, throwing magma tantrums under the sea, while at the same time delicately sculpting coral reefs, like a chef flipping pancakes with one hand and painting miniatures with the other. It's as if the planet couldn't decide whether to be a pyromaniac or an artist, so it chose both. But in the Jurassic, all of that was still far ahead. The world was young, restless, and beautifully balanced on the edge of change. Beneath its calm blue surface, tectonic forces shaped the bones of tomorrow. Every ridge, every trench, every coral outcrop was a promise written in stone, a reminder that even the deepest oceans are temporary, that the Earth itself is both the painter and the canvas. So as we drift above the shadowed ridges of Panthalassa and the glowing newborn basins of Tethys, imagine the silence, the sound of nothing but water and fire negotiating their endless partnership. The seafloor shifts beneath us, quietly writing the story of continents yet to be born. Somewhere below, a volcano hums. Somewhere above, the first reef begins to bloom. Panthalassa, for its part, might have been the straight man in the act, vast, stoic, endlessly deep, while Tethys was the lively apprentice, constantly experimenting, spilling lava here, raising islands there, whispering to the continents, "Come closer." No, not that close, until one day, inevitably they collided. And in between, just for a moment, the Earth seems to whisper, "Look, but gently. The world is still under construction." Oceanic climate, warm waters and restless currents. Close your eyes for a moment and imagine the world during the Jurassic, not as the static globe we see on maps, but as a living, breathing organism covered in warm, shimmering seas. The air is thick with carbon dioxide, the oceans stretch wide and deep, and the temperature of the water itself hums with energy. This is not a cold planet, this is a greenhouse Earth, a blue-green sauna where the average surface temperature of the seas lingers somewhere between 20 and 30 degrees Celsius. In today's world, that would make for a perfect tropical vacation. In the Jurassic, it was simply the default setting. If you could drift along one of these Jurassic currents, you'd feel the planet's pulse beneath you. Water moved not a single flow but as a symphony of streams, some rushing, some meandering, all interconnected. Near the equator, surface currents glided like serpents of molten glass, hot and lazy. Closer to the poles, though poles might be a generous term for their hazy boundaries, the water cooled just enough to sink, slipping quietly into the depths before traveling thousands of kilometers beneath the surface. This interplay of rising and sinking, heating and cooling, created a vast underwater circulation, an early ancestor to the global conveyor belts that still move our oceans today. The warmth of the Jurassic oceans wasn't just pleasant, it was profound. It reached into every current, every layer, every ripple that touched the sunlit surface. The high levels of carbon dioxide, many times greater than those of our modern atmosphere, acted like a planetary blanket. The gases trapped sunlight and turned it into heat, which poured into the sea, radiating downward through waves that shimmered with a greenish hue. The result was a world that never really cooled down. Nights were mild, winters almost non-existent, and the boundaries between climate zones blurred into one long summer. The oceans of this time were not only warm, they were dynamic, restlessly alive with movement. When the supercontinent Pangaea began to split apart, it didn't just rearrange geography, it rewired the entire planet's system of oceanic circulation. Great channels opened where continents drifted, creating corridors for seawater to flow, swirl, and mix. Where once Panthalassa had been a vast, relatively uniform ocean, new routes now encouraged complexity. Warm equatorial waters moved freely into higher latitudes, spreading heat like a slow-moving conveyor belt. The difference, however, was scale. Jurassic oceans moved with more vigor. Because the continents were still drifting apart, the shapes of basins and coastlines constantly changed, which meant that currents were always adjusting. It was as if the planet couldn't decide which direction to spin its water, so it tried all of them at once. Warm waters curved around promontories, funneled through seaways, and tangled into gyres that stirred nutrients from the deep. It was chaotic, yes, but it was also productive. The stronger the current, the richer the sea became. Think of it like the planet's version of coffee percolating. Heat from the interior drove convection below, while sunlight warmed the top. The two forces together created circulation cells that bubbled and rolled through the water column. The boundary between warm surface waters and the cooler depths, known as the thermocline, was thick and uneven, rippling like silk. In some regions it dipped low, allowing surface waters to draw in oxygen from the air. In others, it rose close to the surface, trapping heat and slowing the exchange of gases. The result was a world of contrasts, layers upon layers of liquid motion, each with its own rhythm and temperature. It's tempting to imagine that such warmth would have turned the oceans into stagnant, glassy pools, but that would be a mistake. Warm water, though less dense, was being mixed continuously with cooler upwellings from below. And those upwellings, those great silent elevators of the deep, were the lifeblood of the Jurassic marine climate. They rose along continental margins and newly formed rifts, carrying with them dissolved minerals and nutrients from the abyss. When they reached the surface, sunlight met chemistry, and the stage was set for abundance. The ocean surface glittered with sunlight, but beneath that glitter was constant motion. Winds blowing across the warm seas, steady, strong, and often relentless, pushed surface waters aside and drove Ekman transport, that sideways deflection caused by Earth's rotation. As surface water shifted, deep water rose to replace it, bringing nutrients up like an ancient conveyor of life. It's almost as if the planet whispered to the seas, "Move, stir, feed," and the seas obeyed. The circulation patterns themselves might have looked like a tangled braid of blue ribbons from above. In the northern reaches of Tethys, narrow channels directed water east to west, while in the south, Panthalas's gyres spun in broad, looping arcs. Along Panjar's edges, newly opened seaways acted as funnels, channeling warm equatorial water toward higher latitudes. These currents carried not just heat, but also gases, oxygen, carbon dioxide, methane, blending the atmosphere and ocean into one giant breathing system. Carbon dioxide wasn't just a player in the atmosphere, it was deeply involved in the chemistry of the ocean itself. As CO2 dissolved into seawater, it reacted with minerals and shifted the delicate balance of acidity. The Jurassic Ocean was likely a little more acidic than today's, though still within the comfort zone for the carbonate-forming organisms that would later dominate reefs and shells. But what that slight acidity did accomplish was fascinating. It made the ocean a more effective heat sink. The carbonic acid formed in the water absorbed and redistributed energy, making the upper layers warmer, more stable, and more able to retain that precious solar warmth. The high CO2 levels did more than heat the water. They also amplified evaporation. Warm water loses moisture quickly, feeding clouds and rainfall along the coasts, but leaving the open ocean glimmering under relentless sunlight. The result was a constant tug-of-war between evaporation and precipitation, between salt left behind and fresh water falling from the sky. These fluctuations created subtle density differences that further fueled the circulation. The saltier water sank, drawing oxygen-rich surface water down with it. The less salty water, lighter and buoyant, drifted back up. The entire ocean, from surface to abyss, was a living spiral of convection. At the equator, the effect was dramatic. Warm air rose, carrying moisture upward, while trade winds blew steadily from east to west. Beneath them, the sea responded with parallel streams, great tongues of water stretching across the planet. It was the age of the supercurrents, powerful and persistent, sculpted by a planet that was learning to breathe through its oceans. These currents didn't just transport heat, they redistributed everything, nutrients, gases, and even traces of volcanic dust, carried from distant eruptions. Each current was a messenger, carrying the story of one ocean basin to another. Every few million years, the dance changed tempo. As continents drifted farther apart, the shapes of the oceans altered the flow. A current that once meandered peacefully might suddenly accelerate through a narrowing channel, like a river forced between canyon walls. Temperature gradients sharpened, then softened again. Oceanic fronts, the boundaries where warm and cool waters met, shifted like migrating shadows. If you could map the flow of the Jurassic oceans over time, it would look less like a map and more like a heartbeat, pulsing, irregular, alive. Every swirl and eddy had a purpose. The breaking apart of Pangaea didn't just open new oceans, it reshaped wind belts and heat distribution. Warm water pooled in basins near the equator, creating regions of persistent upwelling along the continental edges. Those zones were like natural feeding grounds, where dissolved carbon and minerals surfaced in shimmering plumes. The physics of it all might sound complex, but the principle was simple. Movement brings renewal. Still water is silent, but moving water speaks. The Jurassic Ocean was never quiet. Temperature gradients between equator and pole remained smaller than today, thanks to the greenhouse effect's even distribution of warmth. That meant fewer violent storms, but more stable, long-term circulation systems. Instead of seasonal hurricanes, the Jurassic likely had slow, monumental oceanic oscillations, currents that shifted course over centuries, perhaps millennia. Imagine the ocean not as a stormy sea, but as a vast, muscular creature turning in its sleep. To modern eyes, the Jurassic Sea might have seemed strange. The warmth reached all the way to higher latitudes, meaning there were few icy poles. Instead of cold, nutrient-poor polar waters sinking to drive global circulation, the Jurassic relied on subtler gradients, differences in salinity and gentle shifts in temperature to move its waters. Yet somehow it worked. The oceans churned and mixed, and oxygen spread efficiently through the surface layers. The deep ocean may have been sluggish by comparison, but even there, gentle currents traced slow, patient paths through the darkness. Beneath the waves, the chemistry reflected the warmth. Dissolved gases equilibrated differently under higher temperatures. Oxygen levels near the surface were healthy, but deeper down, reduced circulation meant that certain regions might have grown oxygen poor, forming local pockets of anoxia. In modern terms, we might call them dead zones. But in the Jurassic, they were simply part of the ocean's natural rhythm. They stored carbon, recycled nutrients, and contributed to the planet's ongoing geochemical balance. At times, the CO2-driven heating created small but significant stratifications, thin thermal barriers that trapped warmth at the top and limited mixing below. In these layers, the water was almost syrupy, holding heat like a glass ceiling. But storms and tidal forces, driven by the moon's gravitational pull, kept breaking these layers apart, recharging the balance. Each disturbance, each passing storm front, each tectonic pulse was like a planetary breath. In, out, mix, repeat. Even sound behaved differently in such a sea. Warm water carries vibrations farther and faster, so if one could listen underwater during the Jurassic, the ocean would have been a symphony. Deep rumbles of shifting currents, faint groans of thermal expansion, perhaps even the crackle of bubbles bursting where heat escaped from the depths. If the ocean had a voice, it would have sounded like slow laughter. Currents shaped everything they touched. Though we'll leave the ecosystems for another time, it's worth noting that these moving waters were the unsung engineers of the Jurassic world. They carried oxygen from air to sea, carbon from sea to sky, and heat from equator to pole. They connected the surface to the depths, the continents to each other, and the planet to itself. The Earth's circulation system, its pulse, its breath, its rhythm, was in those waters, and it was beautiful. From above, sunlight dappled the ocean in gold and turquoise, while beneath, unseen rivers of warm and cool water twisted and merged. The motion was ceaseless but graceful, never hurried. In the grand choreography of the Jurassic, the ocean was both dancer and stage. And humor, yes, the planet had plenty. The CO2 blanket that made the seas warm was like the Earth saying, "Don't worry, I've turned up the thermostat. It's all inclusive now." Of course it overdid it, as Earth often does. The result was an ocean that simmered rather than chilled, a world where the concept of cold water was nearly extinct. But in that warmth, the ocean's circulation thrived. The energy of heat became motion, and motion became the quiet machinery of life's foundation. Somewhere in that vast expanse, a current shifted slightly, turning a degree warmer. A little faster. The planet adjusted. The ocean whispered back, "I'll handle it." And it did, for millions of years. The Jurassic seas carried the planet's warmth, mixed its elements, and set the stage for the worlds that would follow. So when we think of the Jurassic today, we often picture roaring dinosaurs and lush ferns, but perhaps we should picture the sea instead, vast, warm, restless, and alive with invisible energy. Its surface shimmered like liquid glass, and beneath, the great conveyor of heat and chemistry rolled onward, heedless of continents or time. In the end, that's what the Jurassic Ocean was, a grand experiment in motion, warmed by greenhouse gases, stirred by drifting continents, energized by sunlight and gravity. It became a masterpiece of planetary balance. Not too calm, not too violent, just warm enough to hum. If you were to dive into those waters, you'd feel it instantly. The heat against your skin, the subtle push of unseen currents, the faint metallic tang of carbon dissolved in salt. And if you tried to swim against the flow, well, good luck. The Jurassic Ocean might gently laugh and say, "You can try, but I've been doing this for hundreds of millions of years." The oceanic ecosystem, food chains, and the endless battle for survival. It was a world of warm water and restless motion, a planet forever on the move. The ocean didn't just respond to the Earth's climate, it was the climate, and in its endless swirling, it carried the memory of a world that thrived on warmth, energy, and the slow, generous churn of time itself. If you could shrink yourself small enough to drift among them, you'd find an alien garden, cells spinning and dividing, catching light with tiny molecular nets, pulsing with the chemistry of survival. Some are armed with spines, others with shells made of silica, elegant little glass houses that glint in the sunlight. They live fast and die faster, but their numbers are beyond imagination. A single teaspoon of seawater could hold thousands of them. In a sense, they are the ocean's heartbeat. Too small to notice, too essential to ignore. Picture the Jurassic Ocean as an ancient arena, vast and glittering, where every ripple hides a hunter and every shimmer of light could be the last thing a small creature ever sees. Beneath its calm blue surface lies a world of relentless motion, a living web of hunger, growth, and chance. Beautiful, yes, but also brutal, a place where survival is both an art and an accident. Everything begins with something tiny, something almost invisible: phytoplankton. These microscopic drifters, floating near the sunlit surface, are the quiet architects of life. They don't roar, or chase, or hide. They simply exist, turning sunlight into sugar, carbon dioxide into food, and the ocean itself into a living factory. To the untrained eye, they seem insignificant, a green haze in the water, but collectively they are the true kings of the Jurassic Sea. Every breath of oxygen, every mouthful of meat in that ancient ocean traces back to their quiet labor. The small fish and cephalopods follow this feast. Picture shimmering schools of early ray-finned fish darting like liquid silver, mouths open, eyes sharp. They feed on the drifting clouds of zooplankton, weaving in and out of invisible borders of danger. Their scales flash like mirrors, confusing predators. But no disguise lasts long. In the Jurassic Sea, a shadow passes overhead, larger, faster, patient. Floating alongside them are the zooplankton, tiny animals that drift wherever the currents carry them. They are the first link in the food chain, the perpetual grazers of the sea, feeding on the green tide of phytoplankton. Many are transparent, their organs faintly glowing in the filtered light, their movements like slow, delicate dances. But don't be fooled by their grace. When night falls and the upper waters grow dark, these creatures rise in one of the most astonishing events in Earth's history: the daily vertical migration. Every evening, trillions of plankton ascend toward the surface to feed, and every morning they retreat to the depths again, fleeing invisible jaws. It's the largest movement of life on the planet, and it happens quietly, every single day. Enter the hunters. This is where the marine reptiles reign, the undisputed titans of the Jurassic Seas. Their silhouettes cut through the water like blades, their eyes unblinking, their teeth like rows of knives. Some are built for ambush, others for pursuit. The Pliosaurs, with their long necks and paddle-like limbs, glide silently through the gloom, their movements smooth as silk. They are the assassins of the deep, patient and elegant. A school of fish passes above, unaware. The plesiosaur rises slowly from below, body still as a ghost. Then, with a sudden burst, the long neck lashes forward, a flash of motion, a whirl of bubbles, and one fish is gone. Dinner, perfectly executed. The middle ranks of the oceanic food chain are a tumult of motion. Here, Speed means survival. Sleek, torpedo-shaped fish chase. Smaller fish, squid-like cephalopods launch themselves forward with jets of water, tentacles unfurling like nets. Tiny crustaceans scuttle near floating debris, scavenging for scraps. In this tier, everything eats and is eaten. You can almost hear the ocean whisper its cruel lullaby. Keep moving, little one. Someone's always watching. But the real drama happens higher up, in the dim blue depths where sunlight fades and giants prowl. But not all battles are won by size or speed. Some creatures survive through armor, cunning, or sheer stubbornness. Ammonites, the coiled-shelled cephalopods of the Jurassic, are a perfect example. They drift with the currents, their delicate tentacles exploring the water like curious fingers, filtering tiny prey from the plankton clouds. When danger approaches, and danger always approaches, they retreat into their spiral shells, sealing the entrance with a hard, calcified plate. It's not foolproof. One bite from a predator's jaws can still crack them open. But sometimes it's enough. Sometimes luck favors the shell. Elsewhere, Ichthyosaurs, shaped like dolphins but armed with jaws of steel, patrol the open ocean. They're the sprinters of the sea, cutting through the water at speeds that would shame a modern marlin. Their eyes, enormous and adapted to the dim light, catch every flicker of movement. They rely on ambush, precision, and sheer velocity. A single flick of their tail sends them hurtling forward, and another life disappears into the darkness. The ammonite's shells also play another role. They act like little submarines, controlling buoyancy with chambers filled with gas and fluid. With this built-in control system, they can float effortlessly or sink into deeper layers when things get too lively near the surface. In a world of tooth and claw, they've mastered the art of discretion. Below the surface, competition is constant and merciless. The nutrient-rich waters, stirred by the great ocean currents, spark blooms of plankton that ripple up the food web. But where there's plenty, there's also rivalry. Schools of fish compete for feeding grounds. Predators stalk each other as much as their prey. Even microorganisms wage chemical warfare. Some phytoplankton release toxins to outcompete their neighbors. It's an underwater arms race, and everyone, from the smallest to the largest, is armed in some way. The food web of the Jurassic Sea is complex, but beautifully efficient. At its base, the phytoplankton trap energy from sunlight. Tiny grazers convert that energy into motion. Small predators turn it into muscle, and the great reptiles at the top turn it into domination. When one creature dies, its body sinks, becoming food for scavengers and decomposers that live in the twilight depths. Their bacteria and small crustaceans strip it to the bone, returning its nutrients to the cycle. In time, even the bones themselves fall into the mud, enriching the seafloor that will one day become stone. Nothing is wasted. In this ancient world, life feeds on death, and death feeds on life. In this grand ecological theatre, adaptation is everything. A creature that swims a little faster, hides a little better, or senses a little sharper gains a fleeting advantage. Some evolve streamlined bodies to cut through the water with minimal effort. Others develop camouflage patterns that blend into the shimmering light. The surface waters, rippling with sunlight, create an optical illusion that many creatures explore. Predators from below can barely distinguish outlines against the bright sky, while prey from above see only a mosaic of shifting blue shadows. It's a game of light and movement, a silent contest that never ends. Higher up, a plesiosaur glides silently, its flippers undulating like wings. Below it, a group of smaller reptiles patrol the shallows, snapping at anything that moves. Above them, near the surface, schools of belemnites dart about, their torpedo-shaped bodies leaving trails of ink in moments of panic. The scene is constant motion, constant negotiation, the physics of survival made visible. It's easy to romanticize it, to picture the Jurassic Ocean as a grand ballet of nature, each player in perfect synchrony. But the truth is far messier. The water is full of chaos, clouds of sediment stirred by movement, flashes of silver as prey scatter, the occasional swirl of blood vanishing into the current. The ocean floor is littered with shells, bones, and shadows. Yet somehow, From this chaos emerges balance. Each predator has its prey, each scavenger its meal, and the system endures. Even in the tiniest details, the ecosystem is ingenious. Some fish form schools not out of friendship, but survival. Thousands of bodies moving as one confuse predator's vision, making it hard to single out a target. The trick works until it does. A fast predator doesn't need to see clearly. It just needs to lunge into the glittering mass and hope for impact. Statistically speaking, it will hit something. The ocean roams on such odds, probability, instinct, and timing. But not every interaction ends in violence. The Jurassic Sea is also full of quiet partnerships. Tiny crustaceans hitch rides on larger animals, feeding on parasites that would otherwise slow them down. Some fish trail behind massive predators, snapping up leftovers from their kills. Even the drifting carcasses of the fallen become floating oases, attracting swarms of scavengers in a temporary festival of feeding. In death, as in life, nothing goes unused. And through it all, the plankton keep working, invisible yet indispensable. Without them, the whole network collapses. They are the thread that holds everything together, the invisible foundation beneath the spectacle. You could remove any predator and the ocean would adapt, but remove the plankton and the entire symphony stops mid-note. The deeper you go, the quieter it gets, and the stranger. Down in the dim zones where sunlight fades to green and then to black, the rules shift again. Here, slow-moving creatures dominate, conserving energy in the cold, dense water. Predation becomes a game of patience. Jaws open in silence. Bodies drift closer. A flash, a snap, a life extinguished. The deep doesn't shout, it whispers. Up above, the surface is alive with light. The day begins with the shimmer of phytoplankton, the grazing of zooplankton, the chase of fish, the ambush of reptiles. The night falls, and the cycle reverses. It's not so different from the ticking of a clock, each layer of the ocean marking time with motion, each species part of a grand, unending rhythm. If the Jurassic Sea could speak, it might say hunt or hide, swim or sink. Every moment counts, and it would be right. Even humor finds its place here. The Pliosaurs, elegant and terrifying, might seem like royalty of the sea, until you realize how ridiculous they look when turning sharply, their long necks twisting awkwardly like oversized periscopes. The ammonites, meanwhile, are the introverts curled safely inside their shells, muttering, "You go ahead and fight. I'll be fine right here." And perhaps the plankton laugh the hardest, invisible, innumerable, and utterly essential, watching the chaos above them and thinking, all that drama, and they still depend on us. So if you ever find yourself imagining that world, picture not a single creature, but the whole, the endless churn of life in liquid form. The plankton blooming in invisible fields, the small fish darting through beams of sunlight, the predators lurking in the half-light, jaws poised, the ammonites drifting, the Pliosaurs waiting, the Ichthyosaurs slicing past in flashes of power. In the grand theatre of the Jurassic Ocean, every role mattered. Energy flowed from light to life to predator to decay, then back again. It was a closed system, elegant in its cruelty, sustained by motion and chemistry and chance. Each day, countless battles were fought and lost. Each night, countless more began. The sea forgot nothing, yet it forgave everything. It was not a world of peace, but it was a world of perfection, a self-sustaining cycle of energy and survival that made the Jurassic Seas pulse with vitality. Every meal was a risk, every heartbeat a triumph. And somewhere, perhaps, if you listened closely enough, you might hear the ocean's laughter, soft and knowing, carrying the oldest truth of all, the curious creatures, ammonites, and the ancient cephalopods. Imagine a seashell, so perfect that nature kept reinventing it for hundreds of millions of years. Spiral upon spiral, it curls around itself in flawless symmetry, each chamber a mathematical whisper, each curve a small miracle of evolution. That, in essence, is the ammonite, the swirling icon of the ancient ocean. These creatures lived through eras that reshaped continents and climates, floated through seas that no longer exist, and left behind fossils so beautiful They seem almost designed for jewelry rather than survival. Eat or be eaten. That's the game, and it's been playing for hundreds of millions of years. But make no mistake, the ammonite was no delicate trinket. It was a survivor, a tough little voyager in a perilous world. Picture it, a soft-bodied creature hidden inside a coiled fortress of shell, tentacles unfurling like ribbons in the water. It was both shy and audacious, armored yet graceful, drifting and hunting in equal measure. If the ocean were a marketplace of evolutionary ideas, the ammonite was one of nature's best sellers, stylish, efficient, and endlessly adaptable. The ammonite's shell was its defining feature, a masterpiece of both engineering and art. Externally, it resembled the familiar shape of a nautilus, but internally it was far more complex. The shell was divided into chambers by thin walls called septa, each one marking a stage of the creature's growth. The animal itself occupied only the outermost chamber, while the inner ones were filled with gas and fluid that it could adjust to control buoyancy. In essence, the ammonite had its own personal submarine, a biological ballast system that allowed it to float effortlessly, sink when necessary, or rise toward the light. The story of ammonites begins long before the Jurassic, but by that time, they were already veterans of the sea, thriving across nearly every corner of the planet's oceans. Some species were small enough to fit in the palm of your hand, delicate as seashell earrings. Others, however, grew enormous, 2 meters across in some cases, shells large enough for a child to curl up inside. To imagine such a creature gliding through the water, you have to think in spirals, a floating coil, iridescent in the filtered sunlight, its tentacles probing the water ahead like curious fingers. Their eyes, though small, were sharp. Cephalopods are known for their keen vision, and ammonites likely shared that advantage. They could detect movement, shadows, and possibly even subtle differences in color. For an animal surrounded by threats, awareness meant survival. The Jurassic Ocean was no playground. Hungry fish, marine reptiles, and other cephalopods were everywhere, and each ammonite had to balance between staying hidden and finding enough to eat. If you've ever admired the spiral of a snail shell or the curve of a galaxy, you've glimpsed the same geometry that shaped the ammonite. The logarithmic spiral, a pattern that expands but never changes its form, governed the way its shell grew. Each coil was an echo of the one before, scaled perfectly to fit. Nature rarely deals in perfection, but here it came close. It's hard not to suspect that the universe, for a brief and whimsical moment, decided to show off. Despite their elegance, ammonites were not fragile creatures drifting aimlessly in the current. They were predators, small ones perhaps, but predators nonetheless. Their diet consisted of plankton, tiny crustaceans, and other small organisms suspended in the water. Using their numerous tentacles, they would snatch their meals from the drifting soup of life around them, pulling food toward a tough, parrot-like beak hidden within the soft folds of their body. The process was methodical, almost polite. Grab, nibble, and swallow. To do so, they lived in a variety of habitats. Some species stayed close to the seafloor, gliding just above the sand where they could search for detritus or small bottom dwellers. Others ventured into the open ocean, drifting with the plankton-rich currents where sunlight filtered down in shifting gold. Their shells, while protective, made them somewhat cumbersome swimmers. They likely relied on jet propulsion, expelling water through a funnel-like siphon, much like modern squids and octopuses. It wasn't fast, but it was efficient, a dignified glide rather than a frantic dash. Inside, the ammonite's body was a soft, muscular mass, anchored to the shell by a cord called the siphuncle. This structure connected all the chambers, allowing the animal to adjust the mixture of gases within them. It's a bit like having an internal control panel for your own personal submarine. Need to rise? Pump in more gas. Need to sink? Add water. Nature, it seems, had already invented buoyancy control long before humans dreamed of diving bells or submarines. The shell itself was both a blessing and a curse. It provided safety, yes, but also made them prime targets. Many predators could recognize that glossy, coiled silhouette from a distance, a floating prize filled with tender meat. Some ammonites developed thicker shells, their walls reinforced with intricate, folded sutures that gave the fossil its characteristic wavy pattern. These sutures weren't just decorative, they strengthened the structure, allowing the ammonite to withstand pressure, and perhaps the crushing jaws of attackers. Others took the opposite approach, evolving lighter, thinner shells to enhance agility and speed. In the evolutionary arms race, both strategies had merit. Some survived by endurance, others by evasion. And catastrophes came often. Ocean chemistry shifted, currents changed, entire food chains collapsed. Through it all, ammonites adapted, diversified, and returned stronger than before. They were, in a way, the comeback artists of prehistory, the ones who refused to stay down. The fossil record shows wave after wave of ammonite radiations, each one more elaborate than the last. Some species grew spines, others ridges or ribs, perhaps as defense or simply as decoration. One suspects that the ammonites were not above showing off a little. Yet for all their precision, ammonites were also whimsical. Their shells came in a stunning variety of shapes, some tight and compact, others loose and uncoiled, even helical or irregular. It's as if evolution occasionally got bored and decided to experiment. Let's twist this one sideways. You can almost imagine the Earth thinking, let's see what happens. Sometimes the results worked, sometimes they didn't. But that's the beauty of life. Trial, error, and the occasional masterpiece. Ammonites reproduced in staggering numbers. Like modern cephalopods, they likely laid egg clusters, tiny translucent spheres that floated near the surface until the hatchlings emerged. The young ammonites, barely visible specks with minuscule shells, joined the planktonic community, drifting wherever the currents carried them. For a time, they were indistinguishable from the microscopic life they fed upon. Many would never make it past their first few days, snapped up by filter feeders or small fish. But enough survived to ensure the species endured, generation after generation, through cycles of boom and catastrophe. But even perfection has limits. The shells, for all their strength, could not withstand every assault. Large predators develop crushing teeth and powerful jaws capable of cracking them open like nuts. The evidence remains in the fossils. Shells with punctures, fractures, and bite marks frozen in time. It's a sobering reminder that even the most elegant armor is only as good as the danger it meets. And yet, when their end finally came, it was sudden and absolute. Around 66 million years ago, the same cataclysm that ended the reign of the dinosaurs wiped out the ammonites too. The asteroid impact, the darkened skies, the acidified seas, the perfect storm. Their larvae, which depended on sunlight and plankton, couldn't survive the sudden collapse of the food chain. Their shells, once symbols of endurance, became tombs. But what an afterlife they had. Fossilized, polished, and preserved, ammonites became storytellers in stone. They remind us not of extinction, but of persistence. Still, the ammonites endured for more than 300 million years. They survived multiple mass extinctions, each time evolving into new forms. Some lived near coral reefs, others in the open sea, and still others in deeper, darker waters where sunlight barely reached. They colonized every marine environment Earth had to offer. Their resilience became part of the planet's memory, a testament to evolution's stubborn creativity. Now let's not forget their kin, the ancient octopuses and squids that shared the ocean stage. The ammonites' lineage is part of a larger family, the cephalopods, the thinkers and shapeshifters of the marine world. Modern octopuses, cuttlefish, and squids are their distant relatives, carrying forward the same cleverness in new, shell-less forms. But during the Jurassic, the oceans still belonged to those who wore their homes on their back. There's something irresistibly human about ammonites. Maybe it's the spiral, that endless curl that draws the eye inward, a shape that feels both familiar and infinite. Maybe it's the idea of carrying your home with you, of finding safety within your own design. Maybe it's the quiet irony that these creatures long gone still decorate our mantles, museums, and necklaces, tiny echoes of ancient seas turned into art by both nature and time. The early octopuses were mysterious creatures, rarely fossilized because their soft bodies left little trace. But what we know suggests they were already experimenting with intelligence, developing complex nervous systems, keen eyesight, and startling dexterity. They didn't need shells, they had minds. If ammonites represented the armored engineers of the sea, these early octopods were its improvisers, elusive, curious, and adaptable. Together they formed a strange duality in the Jurassic Ocean, one enclosed and cautious, the other bare and bold. If you ever hold an ammonite fossil in your hand, take a moment to think of what it once was. Not just a pretty spiral, but a life, a creature that floated through ancient sunlight, hunting invisible prey, dodging invisible danger. Inside that spiral once pulsed a beating heart, a flickering brain, and a creature that spent its days doing what all life does: eating, hiding, surviving. The beauty we see in the fossil is a side effect of its practicality. Nature, in a rare moment of overlap, made something useful and made it gorgeous. And there's humor in that too. Imagine an ammonite and an early octopus meeting in the shallows, the ammonite bobbing gently, shell gleaming, the octopus watching from a crevice with all 8 arms folded, unimpressed. The ammonite might whisper, "Nice camouflage," and the octopus might reply, "Nice rock collection." Evolution loves irony, and it served both well. There's also an almost cosmic elegance to the ammonite's design. The spiral pattern it follows, the logarithmic spiral, appears everywhere, in galaxies, hurricanes, flowers, fingerprints. It's the geometry of growth, the mathematics of becoming. To look at an ammonite is to see the universe practicing symmetry. It's as if, billions of years before humans arrived, the cosmos decided to doodle a perfect spiral in stone and leave it behind as a hint. If the Earth could whisper one last message to the ammonite, it might say, "You did well, little spiral. You carried the sea's memory in your shell." And if the ammonite could answer, perhaps it would simply spin one last coil and drift away, leaving behind the same silent message it always has. In the end, the ammonite's legacy is everywhere. It's in the fossils embedded in cliffs and mountains, in the jewelry that catches sunlight on someone's wrist, in the scientific diagrams that trace the golden ratio. It's in the very idea that beauty can emerge from survival, that symmetry can be practical, that the simplest shapes can endure the longest. Some scientists believe that ammonites could regulate their vertical position in the water with remarkable precision, rising and sinking in gentle pulses as they searched for food. In that sense, they weren't just drifting aimlessly. They were navigating, adjusting, alive with purpose. Imagine a spiral shell gliding through the dim blue light, tentacles curling and uncurling as it rises, pauses, then descends again. A dance as old as time, choreographed by buoyancy and hunger. Survival is an art, and sometimes art survives. Ichthyosaurs, the ancient dolphins of the Jurassic seas. Picture this: a shape like a torpedo, sleek and shimmering, slicing through the blue depths with the precision of a missile and the grace of a dancer. Its eyes are enormous, black and glossy, built to catch the faintest glimmer of light in the underwater gloom. Its jaws aligned with rows of sharp teeth, designed to seize anything that dares to move. This is not a dolphin, though you'd be forgiven for thinking so. This is an ichthyosaur, a reptile that forgot about the land entirely and claimed the open ocean as its home. The name ichthyosaur means fish lizard, though neither word fits quite right. It's as if the Earth, experimenting with design, looked at the dinosaurs stomping around on land and thought, what if I made one of those, but faster, smoother, and completely aquatic? The result was an evolutionary marvel, a creature that looked more like a modern dolphin or tuna than any of its reptilian relatives. Streamlined, muscular, and terrifyingly efficient, ichthyosaurs were the Formula One racers of the Jurassic seas. An ichthyosaur's body was a masterpiece of evolutionary engineering. Its skin was smooth and hydrodynamic, hugging a body built for minimal drag. The torso tapered elegantly into a powerful crescent-shaped tail fin, used not for gentle swimming but for explosive bursts of movement. Each stroke was a thunderclap of muscle, a jet of motion that sent the animal surging forward through the ancient waves. Its paddle-like limbs, though derived from reptilian legs, were perfectly adapted for steering, trimming and rolling in the water. It could bank, dive and turn with the finesse of a pilot. They came in all sizes, from nimble hunters barely 2 meters long to colossal predators stretching over 20. Imagine something as long as a bus, armed with jaws that could close on prey like a steel trap, powered by a tail that could propel it faster than any human-built submarine. It's enough to make even a shark look humble. The open ocean was their empire, and they ruled it with speed, precision, and a certain cold-blooded charm. That's right, lungs. For all their fish-like grace, ichthyosaurs still breathed air. They would surface periodically to inhale, quick and precise, before vanishing again into the depths. Unlike fish, they didn't need gills. They relied on lungs like modern whales and dolphins. Their nostrils were set far back, allowing them to gulp air with barely a break in stride. Some scientists think they could hold their breath for 20 minutes or more, diving hundreds of meters below the surface. Down there in the dark, they hunted with senses tuned to perfection. If you'd seen one at full speed, it might have blurred into invisibility, leaving only a trail of bubbles and a flicker of light behind. The Jurassic seas were warm and full of motion, and ichthyosaurs were the embodiment of that restless energy. Their very shape tells a story of purpose. A sleek fuselage, a dorsal fin stabilizing the ride, a tail that did the heavy lifting. They were reptiles that had traded claws for control surfaces, scales for skin, and lungs for efficiency. Their eyes were among the largest ever recorded in the animal kingdom. Some were as big as dinner plates, perfectly spherical windows optimized for dim light. Imagine an eye as large as a human head, staring unblinking through the murky blue depths. These eyes, surrounded by bony rings to resist pressure, could track even the faintest flicker of prey. They were night vision goggles built into a living body. And what did they see down there? Dinner, mostly. Ichthyosaurs were apex predators, efficient, relentless, and opportunistic. They hunted fish, squid, and anything small enough to fit into those long, toothy jaws. Their teeth were conical, interlocking like the gears of a well-oiled machine. They didn't chew, they snapped, grabbed, and swallowed. Once their jaws closed, escape was impossible. The prey was yanked in, shredded by rows of teeth, and devoured whole. Speed was their greatest weapon. Scientists estimate that some ichthyosaurs could reach up to 40 kilometers per hour in short bursts. They didn't just swim, they exploded forward. You can almost imagine the silent countdown before a strike, a shadow lurking below, the prey unaware, a flick of the tail, and then gone. The ocean still again, as if nothing had happened. But being a top predator wasn't all glamour and ease. The Jurassic Ocean was vast and unpredictable. Hunting required precision and energy. Ichthyosaurs had to balance power with endurance, stealth with aggression. They may have used ambush tactics, lurking beneath schools of fish before darting upward like a spear. Their streamlined bodies reduced drag, while their tails provided bursts of acceleration. Each hunt was a test of timing, a dance of physics, instinct, and hunger. Despite their dominance, ichthyosaurs were not reckless killers. They were specialists, fine-tuned to the rhythms of the open ocean. Some species may have hunted near the surface, others in the deep, cold layers below. Their bones tell a story of diversity, slender forms for speed, heavier ones for diving. Some had long, narrow snouts packed with delicate teeth for catching small, slippery fish. Others developed broader jaws for crushing prey. Evolution sculpted them with the patience of a craftsman, adjusting design features over millions of years to suit every ecological niche the seas could offer. And they were smart, or at least as smart as a reptile could be. Their brains were relatively large, their senses acute. They likely communicated with body language, flicks of movement, perhaps even sounds. Modern whales and dolphins do this constantly, using clicks and whistles. Whether ichthyosaurs shared that level of communication is unknown, but their social behavior remains one of paleontology's most tantalizing mysteries. Did they hunt alone or in groups? Did they protect their young? Fossil evidence suggests that at least some of them did. Because yes, ichthyosaurs gave birth to live young. Unlike most reptiles, they didn't lay eggs. Instead, they nurtured their offspring internally, giving birth at sea in what must have been a breathtaking sight, a massive reptile emerging from the depths, curling upward toward the surface, and releasing a fully formed baby into the water. Fossils have even captured moments of this process frozen in stone, mothers caught in the act of giving birth, their tiny replicas halfway to freedom. It's one of those rare, intimate glimpses into prehistory that feels almost human. And yet, for all their dominance, there's something strangely poetic about them. They represent one of evolution's greatest transformations, a creature born on land that returned fully to the sea, not halfway, but completely. They abandoned the sun-baked safety of shorelines, and chose instead the cold, endless motion of the deep. In doing so, they reinvented themselves. Their limbs became fins, their bodies torpedoes, their instincts finely tuned to the laws of hydrodynamics. They were reptiles that had mastered the art of being fish without ever ceasing to breathe air. This adaptation made perfect sense. Eggs, after all, don't fare well in the middle of an ocean. By keeping their young inside, Ichthyosaurs ensured the next generation had a fighting chance. The newborns likely swam immediately, instinct guiding them toward the surface for their first breath. From that moment on, they were independent, miniature versions of their parents, ready to face a world that didn't believe in mercy. Their evolutionary success was spectacular. From the early Triassic to the mid-Cretaceous, Ichthyosaurs dominated marine ecosystems. Over time, they diversified into dozens of forms, some with long needle-like snouts, others short and blunt, some sleek and agile, others built for deep crushing dives. They spread across every ocean, from shallow coastal waters to the vast open seas. Wherever you found life, you found Ichthyosaurs. Life in the Jurassic Sea wasn't romantic, it was efficient. Every motion had purpose, every hunt was necessity. And yet, there must have been moments of grace, when an ichthyosaur glided through shafts of sunlight, surrounded by drifting plankton, no prey in sight, no predators above, just motion, balance, and the weightless joy of belonging perfectly to the world around it. Let's pause for a moment and imagine life as an ichthyosaur. You wake in the open sea, suspended in blue silence. The pressure of the water hugs your body. You flick your tail once and surge forward, feeling the resistance peel away like silk. Ahead, a flicker of movement, a school of fish scattering in panic. You accelerate, eyes locked on the nearest target. The world narrows to a tunnel of motion, muscles fire, water rushes past. You open your jaws, and for a split second, time seems to stop. Then, contact, a splash of silver, a ripple of blood, and it's done. Dinner. They were, in their own way, the athletes of prehistory. Their physiology was built for extremes. Their lungs could store vast amounts of oxygen, their blood could tolerate high levels of carbon dioxide, and their bodies likely retained heat, allowing them to hunt in cooler waters. Some scientists even believe ichthyosaurs were warm-blooded, a remarkable possibility for reptiles that would explain their endurance and global reach. Whether through biology or sheer determination, they conquered every temperature, every current, every corner of the sea. Of course, even champions have rivals. The ichthyosaurs shared the seas with other formidable creatures, and competition for food was fierce. But few could match their speed and adaptability. They filled ecological roles that would, millions of years later, be taken up by whales and dolphins. In fact, the resemblance between ichthyosaurs and these modern mammals is one of evolution's most stunning examples of convergent evolution. Different lineages, arriving at the same solution to the same problem, streamlining, tail propulsion, echolocation-like vision. It's as if evolution looked at the blueprint once and thought, perfect, let's reuse this one. And yes, they looked cool doing it. If the Jurassic Ocean had a fashion show, the ichthyosaur would be front row ready, sleek, symmetrical, and just a bit intimidating. Even its silhouette was perfection. The dorsal fins slicing the surface, the tail flicking rhythmically, the eyes glinting like polished obsidian. Earth, in its creative phase, must have smiled when it finished sculpting this one. And yet, like all great dynasties, their reign eventually waned. Environmental changes and shifting prey patterns began to challenge their dominance. New predators emerged, new oceans formed, and the balance of power shifted. But for millions upon millions of years, they were unmatched, swift, intelligent, and breathtaking to behold. It's hard not to feel admiration for them, these ancient swimmers who mastered the sea long before whales dreamed of it. Their fossils, found in cliffs and quarries across the world, still shimmer faintly with the memory of motion. The outlines of their fins, preserved in stone, tell stories of power and grace. When paleontologists uncover an ichthyosaur skeleton, it often looks as though the creature had just paused mid-swim, waiting for the water to return. There's even a touch of humor to their perfection. You can almost imagine an ichthyosaur looking at a modern dolphin and thinking, nice copy. After all, it had the design first. It swam those routes before mammals even existed. The sea remembers its shape. The currents remember its rhythm. If Earth could speak, it might whisper to the Ichthyosaur, "You are my prototype of elegance." And perhaps the Ichthyosaur would respond with a flick of its tail, "Then I was your best work." In the grand theatre of prehistory, it was the ocean's golden child, fast, fierce, and unforgettable. And though it vanished long ago, the shape it left behind still moves among us, carried by every dolphin, every whale, every flicker of silver in the modern sea. Evolution never truly forgot its masterpiece. So the next time you see a dolphin arc gracefully above the waves, think of its ancient shadow. Think of a time when reptiles ruled the deep, when sleek hunters with teeth like knives sliced through tropical seas under alien skies. Think of the Ichthyosaur, the original ocean racer, the first true master of speed and water, a creature that turned survival into an art of motion. The Ichthyosaur's story is one of brilliance and brevity, power and grace, a reminder that even in the most ancient epochs, life already understood style. And if you ever dream of swimming beside one, do yourself a favor. Don't try to race it. It's been 150 million years, and it's still faster than you. Pliosaurs, the long-necked hunters and the silent war for survival. There are creatures that swim through the imagination before they ever swim through the sea, and the Pliosaurs are among them. If you've ever seen a painting of a long-necked reptile gliding through ancient waters, head lifted like a question mark above the surface, you've met one already. They are the mysterious figures of the Jurassic Ocean, elegant, improbable, and perfectly adapted to a life that was equal parts grace and danger. Imagine a creature between 3 and 15 meters long, with a body like a turtle's shell stretched sleek, 4 powerful flippers like polished oars, and a neck so long it seemed to belong to another animal entirely. The Pliosaur was a paradox made flesh, bulky yet buoyant, slow yet deadly, gentle in motion but fierce in intent. If the Ichthyosaur was the torpedo of the Jurassic Sea, then the Pliosaur was its ballerina. It didn't race across the ocean, it glided unhurried, with strokes that looked like underwater flight. Each of its 4 flippers worked in harmony, paddling in a way no modern creature quite replicates. When paleontologists first reconstructed their skeletons, they were baffled. How did an animal with such a strange body swim at all? Later studies revealed that Pliosaurs moved like penguins in slow motion, using all 4 limbs in powerful sweeping strokes. Imagine the steady rhythm of those flippers, pushing water aside like silk, the long neck following with hypnotic grace. Pliosaurs, the long-necked hunters, and the silent war for survival. If the Ichthyosaur was the torpedo of the Jurassic Sea, then the Pliosaur was its ballerina. It didn't race across the ocean, it glided, unhurried, with strokes that looked like underwater flight. Each of its 4 flippers worked in harmony, paddling in a way no modern creature quite replicates. When paleontologists first reconstructed their skeletons, they were baffled. How did an animal with such a strange body swim at all? Later studies revealed that Pliosaurs moved like penguins in slow motion, using all 4 limbs in powerful sweeping strokes. Imagine the steady rhythm of those flippers, pushing water aside like silk, the long neck following with hypnotic grace. There are creatures that swim through the imagination before they ever swim through the sea, and the Pliosaurs are among them. If you've ever seen a painting of a long-necked reptile gliding through ancient waters, head lifted like a question mark above the surface, you've met one already. They are the mysterious figures of the Jurassic Ocean, elegant, improbable, and perfectly adapted to a life that was equal parts grace and danger. Imagine a creature between 3 and 15 meters long, with a body like a turtle's shell stretched sleek, 4 powerful flippers like polished oars, and a neck so long it seemed to belong to another animal entirely. The Pliosaur was a paradox made flesh, bulky yet buoyant, slow yet deadly, gentle in motion but fierce in intent. Pliosaurs were masters of ambush. They lived in environments ranging from shallow coastal waters to the open ocean, but wherever they went, they brought stealth with them. Picture one hovering motionless, just beneath the surface, the sunlight rippling over its mottled skin, the long neck swaying ever so slightly like seaweed in a current. A school of fish passes nearby, glinting in the light. For a moment, The plesiosaur is part of the scenery, calm, harmless, invisible. Then in a blink, the long neck lashes out. The jaws snap shut, the water bursts with bubbles, and the fish is gone. The plesiosaur doesn't roar or thrash. It simply returns to stillness, as if nothing happened. That neck of a neck is what made the plesiosaur unforgettable. Some species had as many as 76 vertebrae in a single chain, giving them a serpentine reach unmatched by any other marine reptile. To see one in motion would have been mesmerizing. The head, small and sharp, drifted ahead of the body like a separate creature, moving with uncanny precision. It could twist, dart, and pivot in ways that defied logic, allowing the plesiosaur to strike from angles no prey could predict. It didn't chase, it waited. Its hunting style was elegant and efficient. The long neck gave it reach, the ability to strike without moving its bulky body and alerting prey. Its head, small but armed with sharp conical teeth, acted like a trap designed to pierce and hold slippery victims. Its diet likely consisted of fish, squid, and smaller marine animals, the sort that never saw danger until it was too late. Some fossils show evidence of stomach contents, tiny bones and scales locked forever in time, telling stories of meals eaten in silence. Some species lived closer to shore where rocky reefs and kelp forests provided cover. Others ventured into the deep blue, far from any coastline, where the water was dark and endless. In those open waters, the plesiosaurs relied on patience and flexibility. They didn't need to chase. They could hover for hours, adjusting buoyancy through their lungs and the density of their bones, letting prey come within reach of that astonishing neck. A flick, a strike, a meal. It was the quietest violence in the Jurassic world. Despite their size, some as long as a city bus, plesiosaurs were surprisingly stealthy. Their bodies, flattened and hydrodynamic, allowed them to move with minimal noise. The rhythm of their flippers was smooth and symmetrical, leaving barely a wake behind. If you could follow one beneath the waves, you might hear nothing at all. Just the faint hum of movement, the whisper of displacement, and the silence of something utterly at home in its element. The plesiosaur's greatest strength was also its most visible weakness. That long neck, so useful for hunting, was also a liability. It was difficult to defend, a target that stretched far from the safety of the body. But nature is clever, and plesiosaurs adapted. Their bodies were muscular and built for sudden bursts of movement. They could roll, twist, and dive with astonishing agility, using those four massive flippers like a synchronized engine of escape. Their skin may have carried patterns that blurred their outlines in the dappled light, breaking up their shape like camouflage. To a predator, they might have looked like nothing more than shifting shadows. Scientists still debate how these creatures moved that famously long neck. Could it coil gracefully like a swan's? Probably not. It was too stiff for elegant loops. Instead, it likely moved in smooth lateral arcs, side to side or slightly up and down, a motion perfectly suited for sudden strikes. The neck wasn't flexible in the way of snakes, but in the way of a whip, not for wrapping, but for snapping. Imagine that, an underwater whip of vertebrae, muscle, and speed, driven by pure instinct. But make no mistake, life in the Jurassic Ocean was not peaceful. For every hunter, there was a greater one waiting. The plesiosaurs occupied a middle tier in the food chain. Formidable predators, but not invincible. They had to be wary, always alert to shadows that might spell danger. Their long necks, though flexible, couldn't twist fast enough to defend against an attack from below. Their only true defenses were awareness and speed. A startled plesiosaur could surge upward in an instant, flippers beating in unison, water churning in its wake. A single lunge could propel its heavy body meters upward, out of reach, or even perhaps briefly into the air. It's strange to think of such a creature surfacing for air. They breathe through nostrils near the top of their heads, rising briefly, perhaps just the tip of the snout breaking the surface. A quick inhale, then back down, back into the silence. From above, it might have looked like a drifting log, a piece of debris, until it moved. The plesiosaur was the phantom of the Jurassic Sea, seen in glimpses and gone again. Their flippers, though, were the true marvel. 4 in total, front and back pairs. They worked together like the wings of a bird. The front ones provided thrust, the rear ones guided and stabilized. This design gave plesiosaurs remarkable maneuverability. They could turn sharply, roll effortlessly, and hover almost motionless. It's been said that they swam like flying underwater, not pushing the water aside but lifting themselves through it, each stroke a controlled glide. It must have been mesmerizing to watch, like a giant bird circling in slow motion, but in a medium far denser and more mysterious. Their skin, according to fossil impressions, was likely smooth and rubbery, similar to that of modern marine reptiles. Some scientists think it may have been patterned with subtle countershading, darker on top, lighter below, a common trick in ocean life, helping them disappear against both the sunlit surface and the dark depths. In the open ocean, invisibility is often the best defense. Pliosaurs also show signs of being warm-blooded, or at least capable of regulating their internal temperature more efficiently than cold-blooded reptiles. This would have allowed them to hunt in colder waters, to travel farther, and to keep their reflexes sharp. Imagine one gliding through the cool twilight zone, where sunlight fades to indigo, muscles warm, eyes bright, ready to strike at anything that moves. They were built not just to survive, but to excel, to be everywhere, in every depth, wherever food could be found. Their fossils, scattered across the world, tell us that they were astonishingly widespread. Europe, North America, Asia, even Antarctica, all have yielded plesiosaur remains. Wherever there was water deep enough to hide, they lived. And they lived long, thriving for over 100 million years. Evolution tinkered with their proportions. Some grew shorter necks and larger heads for tackling bigger prey. Others lengthened their necks even further, refining the art of ambush. It was as if nature kept adjusting the same design, changing the settings, asking, how far can I take this idea? And that idea, the long-necked, flippered hunter, turned out to be one of evolution's favorites. The plesiosaurs didn't dominate by speed or size, but by strategy. They were thinkers, planners in motion. Their hunting method required patience, timing, and precision. It's tempting to imagine a certain intelligence in their movements, the careful stillness, the subtle positioning, the final perfect strike. And yet, for all their mystery and mastery, they were still part of the ocean's endless game of survival. Sometimes they hunted. Sometimes they were hunted. Their sleek forms bore scars, bite marks, and healed fractures that tell of battles survived. A plesiosaur might have spent decades navigating those waters, growing wiser, faster, more careful. Each encounter etched into its story, each escape a quiet triumph. Their reproduction remains a topic of fascination. Some evidence suggests they gave birth to live young, much like other marine reptiles, rather than laying eggs on land. Fossils of pregnant plesiosaurs have been found, their unborn offspring still curled within. This revelation changes everything. It means that the plesiosaurs, like whales, spent their entire lives in the ocean, born, grown, and died without ever touching land. They were true citizens of the sea. Imagine a mother plesiosaur gliding through calm coastal waters, her body heavy with new life, finding a safe, quiet place to give birth. The newborn emerges, small but perfect, a miniature version of its parent. Within moments, it swims on its own, instinct leading it into the current. There's no rest in the Jurassic Ocean, not even for mothers. Life for the young was perilous. They had to grow quickly, learning to move, to hide, to strike. The long neck, still delicate, was both a tool and a curse. It allowed them to reach food easily, but also made them easy targets. Only the strongest survived, but those who did grew into hunters as precise as their parents, repeating the cycle with unbroken rhythm. If the ocean could whisper, it might have told the plesiosaur, stretch farther, wait longer, move slower, patience is your weapon. And they listened. Their entire anatomy was a hymn to patience, a design that said, I don't need to chase, I only need to strike once. For all their ancientness, plesiosaurs have lingered in our cultural imagination like ghosts. The long-necked silhouette gliding through misty water has inspired legends for centuries, from sea serpents in sailors' tales to the infamous Loch Ness monster. It seems we never quite let them go. Perhaps it's because they look both real and otherworldly, familiar enough to believe in, strange enough to haunt us. Humor helps here. Picture a plesiosaur peeking above the waves, long neck craning curiously at a passing boat, eyes wide and unimpressed. Still here? it might seem to say. You took your time. Then, with a flick of its flippers, it slides back beneath the surface, vanishing into history once more. In truth, they were creatures of both beauty and practicality. Everything about them served a purpose. The long neck for reach, the compact body for balance, the flippers for control. They weren't fast, but they didn't need to be. They played the long game, literally. Their entire design was an ode to patience, subtlety, and control. In the chaotic theatre of the Jurassic Sea, there were the silent assassins, graceful, efficient, and utterly unhurried. They were not the fastest, nor the largest, nor the fiercest, but they were among the most patient. And in the ocean, patience is power. So when you think of the Pliosaurs, don't picture monsters or myths. Picture balance. Picture stillness beneath motion. Picture a creature that could wait an hour for the perfect moment to strike. And when it did, it was over in a blink. Even now, their fossils hold mystery. Each skeleton, with its elegant arcs and perfect symmetry, feels almost like sculpture. You can trace the line of the neck with your eyes, follow it to the delicate skull. Imagine it turning, gliding, waiting. There's poetry in that curve, the curve of hunger, of survival, of quiet mastery. I am the stillness before the strike. I am the reach of the unseen, and I never truly left. The Plesiosaur's story ends, like so many others, with extinction. But its image endures, the long neck arching from ancient seas, the flippers cutting through water like wings, the ghost of a creature too strange and too perfect to forget. And if one quiet night you find yourself staring into a dark lake or an endless ocean, you might feel it, that ripple of possibility, that whisper of movement beneath the surface. The Plesiosaur's legacy lingers there, patient as ever, waiting in the deep, as if to say, if the Jurassic oceans were the cradle of graceful hunters and elegant ambush predators, then the seas that followed, the late Jurassic spilling into the Cretaceous, belonged to something far more brutal. Enter the Mosasaurs, the undisputed titans of the ancient seas. Long, muscular, and terrifyingly fast, they were the last great marine reptiles before the curtain fell on the Mesozoic era. Imagine a creature that looked like a monstrous cross between a crocodile, a monitor lizard, and a torpedo. Now make it 17 meters long. Give it jaws full of blades, lungs that could fuel long dives, and a mind built for violence. Congratulations, you've met a Mosasaur. They were the apex predators of their world, the ocean's final boss, the last word in marine dominance before the age of dinosaurs ended. When Mosasaurs arrived, the message was simple. The sea had a new king, and it had teeth. Mosasaurs, the giant sea serpents, and the savage art of survival. At first glance, the mosasaur's shape is deceptively simple: long body, paddle-like limbs, a tail that ended in a crescent fin, and a head that looked far too big for comfort. But that simplicity masked an evolutionary masterpiece. Their bodies were sculpted by millions of years of adaptation, honed for efficiency and destruction. They were true reptiles, descendants of land-dwelling lizards, that had, much like their distant cousins, the Ichthyosaurs, abandoned dry land for the promise of endless blue. Unlike their predecessors, though, mosasaurs didn't just return to the sea, they conquered it. Mosasaurs could reach astonishing sizes, ranging from smaller species around 3 meters long to giants over 17 meters, roughly the length of a subway car, but considerably more bitey. Fossils suggest that their skulls alone could exceed 2 meters in length. Those skulls, hinged by flexible joints, allowed their jaws to open wide enough to swallow prey almost whole. Their teeth were conical and serrated, perfectly designed to grip slippery fish and slice through tougher prey. A bite from a mosasaur wasn't just painful, it was catastrophic. One crunch could shatter bone. Their anatomy was a study in lethal design. The body was sinuous and muscular, built for power rather than elegance. The limbs had evolved into strong flippers that worked in tandem with the undulating motion of their massive tails. That tail, broad and half-moon-shaped, was the engine that drove them forward. A single thrust could propel a full-grown mosasaur several meters through the water in an instant. When they moved, the ocean seemed to part around them. The smaller prey had no chance. Even the larger ones only delayed the inevitable. And they were not picky eaters. Fish, turtles, Smaller marine reptiles, even members of their own species, all were fair game. Their diet reads like a horror story of the sea. Some fossils show stomach contents filled with the bones of other mosasaurs, proof that cannibalism was on the menu. Paleontologists have even found bite marks on mosasaur fossils that match mosasaur teeth. In other words, they weren't just kings, they were also executioners of their own kind. Evolution, it seems, had given up on subtlety and gone straight for apex. But it wasn't just raw power that made them so successful. The mosasaurs were clever hunters. They could move with surprising stealth, despite their size. Their bodies were streamlined, and their swimming style combined the grace of a snake with the propulsion of a dolphin. They used side-to-side motions of their tails to generate thrust, saving their flippers for control and maneuvering. They could glide silently, rising beneath unsuspecting prey before exploding upward in a surge of bubbles and teeth. Imagine the moment: a calm sea, schools of fish drifting lazily in the sunlight, and then without warning a massive shadow rises from below. The water churns, the prey scatters, and a single, unlucky creature disappears in a flash of jaws and foam. The mosasaur doesn't linger. It swallows, turns, and vanishes into the deep, leaving only silence and drifting scales behind. Some scientists think mosasaurs hunted not just by sight, but by sensing vibrations and pressure changes in the water, a kind of biological sonar. This would have made them almost impossible to evade. A fish might flee thinking it had escaped, only to feel a sudden shift in current, the whisper of doom approaching. There was no hiding from a mosasaur. The ocean in their age was a stage built for their performance. They were also remarkable divers. Their bones suggest adaptations for life in deep water, dense ribs for pressure resistance, powerful lungs for long dives, and nostrils positioned high on the snout so they could breathe quickly at the surface before slipping back down. Their eyes were large and forward-facing, indicating keen vision. In the twilight depths, those eyes would have glowed faintly, catching the last rays of sunlight like twin lanterns. Despite their reptilian lineage, mosasaurs shared surprising similarities with modern whales and marine mammals. They gave birth to live young, a necessary adaptation for fully aquatic life. Eggs would have been useless in the open sea, so instead, mosasaur mothers carried their offspring until they were ready to swim. Fossilized remains of pregnant females have been found, with tiny skeletons preserved inside, curled and waiting. It's a strangely tender image in the midst of so much ferocity, a giant predator that began life as something fragile, nurtured within another before being released into the chaos of the sea. And chaos it was. The late Cretaceous oceans were no gentle nursery. The food web was a hierarchy of teeth, and mosasaurs were at the top. They filled the role of apex predator with enthusiasm and brutality. Nothing was safe near them, not even the animals that shared their size range. Smaller mosasaurs likely lived closer to the coast, hunting fish and smaller reptiles, while the larger species roamed the open ocean, following migrations and feeding wherever opportunity presented itself. Some may have specialized in ambush tactics, lurking near the surface where light played tricks on vision. Others may have patrolled the deep, relying on stealth and surprise. Some species developed even more specialized tools. The Mosasaurus hoffmanni, one of the largest, had robust blade-like teeth designed to cut through bone and armor. Others, like Tylosaurus, had elongated snouts and spear-like skulls, ideal for impaling slippery prey. Evolution had essentially turned each type into a different model of destruction, a product line of predation. Their feeding strategy was pure efficiency. Unlike many predators that chased or stalked their prey for long stretches, mosasaurs preferred ambush and blitz attacks. They would accelerate from below, strike hard, and consume fast. Their jaws, powered by enormous muscles, could crush, tear, and swallow with brutal speed. Their teeth curved slightly backward, a small but devastating detail. Once something was inside a mosasaur's mouth, there was no getting out. And yet, in their terrifying way, they were beautiful. Picture one gliding beneath the surface at dusk, the fading sunlight catching the ripples along its scales. Its skin, likely smooth and mottled with patterns, shimmered as it moved. The powerful tail flicked lazily, propelling the creature forward with almost insulting ease. Its eyes scanned the darkness ahead, unblinking and calm. There was nothing in those seas that could truly threaten it. It was not just surviving, it was thriving. For all their ferocity, mosasaurs were also intelligent. Their brain cases suggest advanced coordination and sensory processing, far beyond that of typical reptiles. They could adapt their hunting styles, communicate with their young, perhaps even cooperate in groups. Some scientists speculate that smaller mosasaurs might have hunted in pairs or family pods, herding schools of fish much like dolphins do today. Whether this was true or not, the image is haunting. A group of sleek ancient reptiles circling their prey in a silent ballet of death. Humor, perhaps, is the only safe response to such overwhelming dominance. If the earth could speak to the mosasaur, it might have said, "All right, that's enough teeth. Tone it down," and the mosasaur would have smirked if reptiles could smirk and replied, "But I'm just getting started." Their growth was rapid. Juveniles grew quickly, likely doubling in size within their first few years. Survival demanded it. There was no safety in being small in a sea filled with larger mouths. The young mosasaurs learned to hunt fast or die trying. Every day was a test, every meal an act of endurance. The weak didn't last long, but those that did grew into giants. They also had a flair for drama. When they surfaced to breathe, their movement would have sent ripples across the water, the tips of their snouts breaking the waves like spears. You might have seen a fin here, a shadow there, and then nothing. Just when you thought the ocean was calm, a massive tail would slap the surface, the water exploding in white foam. The seas of the Cretaceous were alive with those moments, brief, violent punctuation marks in an otherwise eternal sentence of blue. What made mosasaurs particularly fascinating was their timing. They appeared relatively late in Earth's history, roughly 98 million years ago, and yet in just a few tens of millions of years, they became one of the most successful marine predators ever to exist. They evolved quickly, diversified wildly, and spread everywhere. From Europe to North America, from Africa to Antarctica, their fossils lie waiting, silent testaments to a reign that ended only when the skies fell and the world changed forever. When the asteroid struck at the end of the Cretaceous, the oceans burned and darkened, the food chains collapsed, plankton died, fish vanished, and the great predators followed. For the mosasaurs, it was the end of the feast. Without prey, even kings starve. Within a geological heartbeat, they were gone. Every species wiped out, but their legacy remains in stone, in the jaws that could crush turtles like fruit, in the skeletons preserved mid-motion, still curved as if swimming. To look at a mosasaur fossil today is to see raw confidence made permanent. The skull, all teeth and hunger. The ribs, broad and powerful. The tail, elegant in its arc. You can almost sense motion frozen in time, a predator caught between breaths. It's hard not to admire the perfection of it. Nature, for once, didn't hold back. It built a creature entirely out of purpose. Swim fast, bite harder, never stop. And that perhaps is why the mosasaur endures in our imagination. It was a reptile that mastered the ocean, a reminder that power and beauty often share the same space. There's something almost cinematic about them. Those massive jaws opening in slow motion, that flash of scales beneath the surface, that terrible grace in motion. They were nature's own special effects, living proof that evolution could design monsters with elegance. Swim hard, bite fast, rule while you can, but somewhere, deep in the Earth's memory, they're still there, cruising through ancient waters, kings of a vanished ocean, the last and fiercest heirs of a reptilian empire. The Earth might whisper their creed even now, carried in the rhythm of the tides. So, if you ever find yourself floating in calm blue water, think for a moment about the seas that came before. Picture a shadow below you, long, sinuous, and purposeful. The sun glints off the waves. For a heartbeat, everything is still. Then from the depths, a massive shape surges upward, jaws opening wide enough to swallow you whole. Don't worry, it's just your imagination. The mosasaurs are long gone. And if you listen closely, beneath the sound of waves, you might almost hear their laughter, low, cold, and eternal. The laughter of the sea's greatest hunters who once ruled a world that belonged only to them. Sharks and ancient fish, the underwater war for survival. If you could dive into the oceans of the late Jurassic and early Cretaceous, the first thing you'd notice after your lungs stopped screaming about the pressure and the temperature is that everything down there was moving, eating, or trying not to be eaten. It was a time when the seas were crowded with teeth and tails, fins and fury. Among this swirling chaos of scales and strategy swam two very different kinds of champions: the sleek, sharp, ancient sharks and the massive, filter-feeding giant fish that dwarfed almost everything around them. They were the duelists and the drifters, the predators and the plankton eaters, coexisting in a world where survival meant either being faster or being so big that nothing dared to take a bite. The story of sharks begins much earlier than the Jurassic. They are older than dinosaurs, older than trees, older even than flowers. By the time of the Jurassic seas, sharks had already been perfecting their craft for over 200 million years. The ocean was their arena, and they had long ago mastered every trick worth knowing. One of the most iconic early sharks of this era was Hybodus, a sleek and cunning predator that patrolled both shallow reefs and the open sea. It was not enormous by prehistoric standards, usually about 2 meters long, but it carried itself like it owned the ocean. Picture a streamlined body, a narrow snout, and 2 dorsal fins each tipped with a sharp spine, like twin spears ready for battle. Its mouth was a toolbox of teeth, sharp ones at the front for gripping prey, flat ones at the back for crushing shells. Hybodus didn't discriminate. If it swam, scuttled, or drifted, it was potential lunch. Its design was pure efficiency. A body shaped for speed, a tail that whipped side to side like a metronome of death, and senses so sharp they could pick up the faintest tremor in the water. Hybodus could detect a struggling fish or a hiding crustacean long before it saw them. It could strike with precision, twisting its body in a sudden burst of acceleration that left nothing but bubbles behind. In an age filled with competition, it was a model of adaptability. But for all its predatory perfection, the shark's greatest strength was not its teeth or its speed. It was its simplicity. Nature rarely needs to reinvent what already works. The shark body plan, streamlined, muscular, endlessly efficient, has barely changed since those Jurassic waters. Every modern shark, from the hammerhead to the great white, is a living echo of that ancient design. Hybodus, cruising through coral shallows and coastal reefs, was already a preview of the ocean's future kings. And yet, even the most formidable hunter needs a world to hunt in, and the Jurassic seas were rich with opportunity. Schools of bony fish, ancient rays, crustaceans, and mollusks filled the water like a living storm. The oceans were productive, full of nutrients, stirred by the shifting continents and warm currents. It was a buffet, and Hybodus was never far from the table. Its eyes, large and unblinking, scanned constantly. Its nostrils tasted the water for traces of blood or decay. It wasn't picky. It was pragmatic. If it could fit into its mouth, it was food. There's a certain humor to sharks when you think about it. They're not malicious, they're just relentlessly practical. In the Jurassic Ocean, that practicality made them nearly invincible. If you were another small fish, your best defense was to stay invisible, to hope that the shimmer of sunlight fooled those ancient eyes for just a few seconds longer. If you failed, the last thing you'd see was the open mouth of Hybodus, ringed with 200 reasons to swim faster next time. And yet, lurking in those same waters were giants, creatures so large that even a hungry shark would think twice before making a move. These were the ancient fish, colossal creatures that turned the ocean into an empire of size. Among them was the mighty Ichthyosaurs, the largest bony fish to ever exist. It was a living leviathan, a gentle one, but still intimidating by sheer presence. Ichthyosaurs was a filter feeder, a creature of calm power in a world of frenzy. Imagine a fish longer than a bus, perhaps reaching 16 meters, swimming slowly through the open ocean with its mouth wide open, filtering clouds of plankton and tiny crustaceans through gill rakers like a living vacuum cleaner. It didn't chase or bite or stalk, it simply drifted, massive and unbothered, turning the chaos of the microscopic into muscle and bone. Its body was a marvel of engineering, broad, tapering, and built for slow, deliberate movement. The tail was huge and crescent-shaped, providing steady propulsion. Its head was wide, the jaws extending forward like a net, and inside, instead of the cutting teeth of a predator, were long bony structures used to strain food from the water. It was the opposite of hybridous in every way, peaceful, ponderous, and utterly indifferent to the drama of the food chain. And yet, its size didn't make it lazy. Moving a creature that large through the water took immense power. The muscles along its sides worked like the pistons of an engine, flexing rhythmically as it moved. The ocean would part around it in slow waves, schools of smaller fish scattering in its wake. Even the predators gave it space, not because they couldn't attack, but because they knew the cost. A bite of Ichthyosaurs would mean broken teeth and wasted effort. It was better to follow in its shadow, snatching at the smaller creatures disturbed by its passage. If the shark was the blade of the Jurassic Ocean, Ichthyosaurs was its mountain. One ruled by speed and cunning, the other by sheer enormity. Together, they formed a perfect balance in the ocean's great machine, the hunter and the grazer, the quick and the colossal, each thriving in its own way. But not every fish of that era was a gentle giant. The seas also teemed with other bony predators, agile and aggressive, some with bodies like torpedoes and jaws that could snap shells clean in half. The early teleost fish ancestors of nearly all modern species were beginning to diversify, experimenting with new forms and feeding strategies. Some were fast swimmers, darting through schools like silver bullets. Others had tough scales like armor, turning their bodies into living shields. The diversity was staggering. The competition was fierce. Every niche in the food chain had a contestant, and evolution was the referee. A slightly sharper tooth, a stronger tail, a quicker reflex, any advantage could mean survival. For sharks like Hybridus, it meant staying ahead of the curve, literally and figuratively. For giants like Ichthyosaurs, it meant relying on abundance and size, turning the planet's smallest life into its largest body. Picture a scene beneath the Jurassic waves. The sun filters through a ceiling of rippling light. A shadow glides beneath. Hybridus, its body cutting a perfect line through the water. Far ahead, a vast silhouette moves slowly, its body like a drifting continent. Lolzik, feeding, quietly, oblivious. The shark circles, curious but cautious. One swipe of that massive tail could turn predator into pulp. For a few moments, the two species share the same space, the hunter and the behemoth, perfectly balanced by nature's design. Then the shark flicks its tail and disappears into the blue, seeking easier prey. It's easy to think of the prehistoric ocean as a place of endless violence, but it was more than that. It was strategy, rhythm, and timing. The sharks and fish that survived did so not by luck, but by learning the rules. Sharks learned to sense weakness. Giant fish learned to avoid confrontation altogether. The balance was delicate, but it worked. Sharks like Hybridus weren't the only players. Some species developed specialized diets. Others targeted shellfish. Some hunted smaller sharks, and still others may have scavenged carcasses drifting from above. Their teeth tell the story, rows upon rows of serrations, ridges, and cusps, each designed for a particular meal. To a paleontologist, a shark tooth is like a signature, a fossilized autograph signed in enamel. And oh, the humor of it all. Picture a Ichthyosaur swimming majestically through the open sea, mouth agape like a cathedral door, filtering millions of plankton, while behind it a tiny Hybridus trails along, nibbling at the leftovers like an opportunistic guest at an all-you-can-eat buffet. The shark, of course, would deny it. But nature has no pride, only pragmatism. In the ancient ocean, every strategy was valid, even if it meant freeloading off a giant. What made the era remarkable was the coexistence of opposites. The same sea that housed gentle giants also bred the sleekest killers. The same food webs that sustained filter feeders also powered high-speed chases. It was a world in motion, where everything from the smallest plankton to the most terrifying predator was connected by hunger and survival. Even the giants had enemies. Juvenile Ichthyosaurs, still growing, would have been vulnerable to attacks. Their sheer size offered safety only once they reached maturity. Before that, the ocean was full of dangers, smaller sharks, swift marine reptiles, and the ever-present possibility of scarcity. The ocean could be generous, but it could also be cruel. The smaller fish of the Jurassic had their own ways of coping. Some swam in enormous schools, moving in synchronized waves to confuse predators. Others developed camouflage, blending into the shimmering light of the surf. A few became fast enough to leap out of the water entirely, escaping into the air for a brief, gasping moment before plunging back down. It was, in a way, evolution's first rehearsal for flight. Through all of it, sharks remained constant. They adapted, but never reinvented themselves. Why would they? They had already found the blueprint for success. They grew larger, faster, sharper, but never fundamentally changed. By the Cretaceous, their descendants would include forms we recognize instantly today. The tiger shark's cunning, the mako's speed, the great white's brutal efficiency, all of it was there, written in the genes of their ancient ancestors. Meanwhile, the giant fish continued their slow, peaceful dominance until environmental changes began to thin their numbers. Warmer oceans, shifting currents, and competition from new species gradually pushed them toward extinction. The seas were changing, becoming less forgiving for the giants and more favorable to the predators, and yet the legacy of both remained. The sharks carried on, their lineage stretching unbroken from those early hybridous forms to the oceans we know today. Every time a modern shark glides past, it carries echoes of that ancient efficiency, the same smooth precision honed in Jurassic waters. The great fish, though gone, left behind fossils that remind us of nature's experiments in scale and serenity, a reminder that even in an age of monsters, gentleness could thrive. In a way, the contrast between sharks and Ichthyosaurs captures the entire philosophy of life in the Mesozoic seas. There were many paths to survival. You could grow sharp and fast, or slow and vast. You could hunt or filter. You could chase or drift. The ocean rewarded creativity, not mercy. If the earth could whisper to them, it might have said, "Find your balance, speed or size, tooth or sieve, chase or drift. But whatever you choose, swim hard." And they did. The hybridus hunted until the very end, darting through ancient reefs with the confidence of a creature that knew exactly what it was meant to be. The Ledesichthys swam with calm indifference, vast and eternal, feeding on the invisible and ruling through stillness. Both thrived, both vanished, but both left their mark on the blueprint of life. And perhaps in that long-ago ocean, they occasionally crossed paths, the shark all angles and motion, and the fish all mass and calm. For a heartbeat in prehistory, they shared the same water, the same sunlit current, the same pulse of the ancient earth. Then, with a flick of a tail, they moved apart, each following its own truth through the blue. The ocean forgets nothing. Its waves still carry their stories of teeth and gills, of patience and power, of the endless, thrilling experiment called survival. And somewhere in those depths, if you listen closely enough, you might still hear the echo of that eternal lesson. Swim fast or grow huge. But whatever you do, never stop moving. Sea turtles and other curious drifters, the art of passive survival. Not every creature in the ancient oceans was built for speed, sharp teeth, or high drama. While some species tore through the waves like living torpedoes, others survived by doing the opposite, by moving slowly, eating quietly, and trusting in armor rather than aggression. Among these serene survivors, one stands out as both symbol and spectacle. The ancient sea turtles, those shelled wanderers who chose patience over power, silence over chase, and leading their slow but steady march through prehistory was the mighty Archelon, the largest sea turtle the earth has ever known. Imagine this gentle giant gliding through the late Cretaceous seas, a living shield, 4 meters from nose to tail, with a leathery shell stretching wider than a car. Its flippers, long and graceful, propelled it not with the frantic strokes of a fish, but with calm, rhythmic sweeps that moved it forward like a drifting kite beneath the waves. Archelon was not built for battle. It was built for endurance, for the long, unhurried passage of time itself. In a world full of predators, it chose an entirely different path. It became a fortress that floated. To see one alive would have been both awe-inspiring and slightly comical. Its head, beak-like and dignified, protruded from its massive body, scanning the water for soft-bodied prey, jellyfish, mollusks, perhaps even drifting seaweed. Unlike the ferocious hunters that ruled the open ocean, Archelon was an opportunist, feeding on what it could catch or graze upon, without much chase. Its mouth wasn't lined with rows of teeth. Instead, it had a strong, curved beak, perfect for slicing through soft food or crushing shells. There was no need for speed when you carried your home on your back. The shell of Archelon wasn't the hard, bony dome we think of when picturing modern turtles. It was more like a framework, a leathery covering stretched over a network of ribs and cartilage. This made it lighter, more flexible, and ideal for swimming. Its size alone was a deterrent. Very few predators could or would dare take on a creature that massive and that well-armored. Archelon didn't need claws or teeth or venom. Its defense was existence itself. And yet, despite their size, these ancient turtles were not lumbering oafs. They were travelers, voyagers of the prehistoric seas. Fossil evidence suggests that they migrated great distances, moving between coastal feeding grounds and open ocean nesting sites. The rhythm of their lives may have been guided by the moon and the tides, just as modern sea turtles are today. Every few years, the females would return to sandy shores, dragging their colossal bodies onto land to lay eggs. A slow and perilous process, but one that had worked for millions of years. There's something almost spiritual about it, a creature that spends nearly its entire life at sea, returning to the land only to ensure that the cycle continued. The hatchlings, of course, had none of their parents' protection. When they emerged from the sand, no larger than a human hand, they faced an immediate gauntlet of danger. Birds, reptiles, and fish all waited for the easy meal. Only a few in 1,000 would survive to adulthood. But those that did could live for decades, perhaps even a century, cruising through ancient currents, slow and unhurried, as if time itself moved at their pace. There's a quiet humor in the idea of a creature that survives by simply outlasting its enemies. Archelon's strategy was almost philosophical. Why run when you can wait? Why fight when you can float? In a world where everything was eating everything else, it found safety in patience. Even the great predators of the time must have looked at it and thought, too much effort. Its environment was complex, a mix of shallow coastal seas, reefs, and open stretches of blue. These waters teemed with life. Schools of fish glittered in the sunlight, ammonites drifted like coiled balloons, and plankton shimmered in vast clouds. The Archelon glided through it all, its massive flippers slicing gently through the water, its dark shell casting a shadow below like a moving island. Occasionally it would pause to rest near the seabed, nibbling on sea plants or rooting through the sand for crustaceans. It was a bottom feeder at heart, an oceanic grazer, slow but deliberate. It's strange to think that something so big and seemingly vulnerable could thrive in a world filled with monsters, but that's exactly what Archelon did. Its shell was a statement, an evolutionary masterpiece of passive defense. Like an ancient tank, it didn't need to attack. It simply needed to endure. The earth in its quiet humor might have whispered to it, if you can't fight, just become too much trouble to kill. And the turtle listened. Archelon wasn't alone in its strategy. The ancient seas were full of other curious, passive creatures, each with its own peculiar method of not dying. There were slow-moving rays, half buried in the sand, blending perfectly with the seafloor until something edible drifted too close. There were strange, jelly-like filter feeders, pulsing gently as they strained microscopic food from the water. There were sea lilies, yes, animals, not plants, anchored to the ocean floor, their feathery arms waving lazily to catch drifting particles. And there were the armored fishes, survivors from earlier ages, still covered in heavy scales like miniature submarines, living relics of a tougher time. All of them shared one thing, the art of stillness. In a violent ocean, stillness was its own form of strength. The predators burned energy in the hunt, fought and bled for every meal, while these quieter creatures simply existed, feeding slowly, evading attention, letting the chaos swirl around them. It was the ultimate act of confidence, to trust the world not to notice you. Archelon's enormous shell was its declaration of independence from the madness of the food chain. It could afford to drift. It could afford to take its time. With lungs the size of barrels, it could hold its breath for long periods, sinking to the ocean floor and resting for hours. When it surfaced, it did so gently, a slow rise, a small exhale, a quiet gulp of air, and then back down again. It was a breathing rhythm older than humanity, older than flowers, older than mountains in their current shape. Its flippers, too, were marvels of design, elongated and slightly curved, built not for bursts of speed, but for the steady, tireless motion that could carry it across oceans. It was not flashy, but it was enduring. The Archelon was a creature designed not to win races, but to finish them long after everyone else had tired and disappeared. Its eyesight was likely keen enough to spot movement in the murky waters, but its sense of smell and touch may have been even more important. Sea turtles can sense magnetic fields, using the Earth's invisible lines as a kind of ancient GPS. Archelon, too, probably navigated by instinct and magnetism, guided by forces beyond human perception. Perhaps it followed warm currents, or the taste of certain waters, or even the subtle pulse of the ocean itself. Whatever the method, it worked. The species thrived for millions of years. And yet, even the calmest seas hold danger. Archelon's size protected it from most predators, but not all. A determined attacker, perhaps a massive marine reptile or an opportunistic pack of smaller hunters, might still test its defenses. Its shell, while sturdy, wasn't indestructible. But Archelon had one more advantage: endurance. When danger loomed, it could dive deep and stay there, its massive lungs supplying oxygen for minutes that felt eternal. Down there in the quiet dark, it was invisible. The predator would circle, wait, and finally give up. Archelon would eventually rise again, serene as ever, as if nothing had happened. It's easy to see why these creatures capture our imagination. They embody a kind of wisdom that feels almost human, a quiet refusal to rush, a calm persistence that outlasts the ages. There's humor in their simplicity, too. Imagine Archelon looking at the frantic predators around it and thinking, "You all worry too much." It was the original minimalist, the monk of the ocean. And yet, for all its peace, life as an Archelon wasn't dull. Every day brought the rhythm of survival, drifting through kelp forests, gliding over coral reefs, basking in the sunlight filtering from above. Perhaps it even enjoyed the gentle sway of the currents, the touch of fish brushing against its shell, the distant echo of underwater thunder. To live slowly is to experience everything deeply, and Archelon had time, endless time, to notice the world around it. In the broader story of evolution, creatures like Archelon remind us that survival isn't always about aggression or dominance. Sometimes it's about adaptability and balance. Nature rewards both the hunter and the hermit. The fast and the patient each have their place, and the sea, vast as it was, always found room for those who preferred to float rather than fight. Some of Archelon's smaller cousins developed their own unique quirks. Some evolved flatter shells to slip more easily through tight reefs. Others became herbivores, munching peacefully on seagrasses near the shore. A few even ventured into freshwater habitats, testing new worlds as the continents continued to shift. Each carried within it the same ancient design: a shell for safety, flippers for freedom, and a steady heartbeat tuned to the rhythm of the tides. The lineage of these ancient turtles survived long after their larger relatives disappeared. When the Cretaceous ended in fire and darkness, Archelon and many of its kind vanished, unable to cope with the rapid changes that followed the Great Extinction. But the spirit of their design endured. The modern sea turtles we know today, the green, the leatherback, the loggerhead, are living echoes of those ancient mariners. When they rise from the deep to breathe, it's as if a whisper from the Cretaceous surfaces with them. And perhaps that's the most remarkable thing about these passive survivors. They are anything but weak. Their stillness is strength. Their slowness is strategy. In an environment that rewards aggression, they remind us that gentleness can be just as powerful. They are proof that survival isn't always about domination. It's about endurance, resilience, and an almost stubborn faith in the rhythm of life. The ancient seas were full of such quiet marvels. Slow-moving sea cucumbers sifted through the sand, turning the ocean floor like living filters. Horseshoe crabs scuttled along the shallows, their design so perfect it barely changed in 400 million years. Sponge-like organisms built reefs that shimmered in the sunlight. Everywhere you looked, something soft, patient, and ancient was thriving simply by existing. If Earth had a sense of humor, and perhaps it does, it might have looked upon these gentle creatures and smiled, saying, "Not every story needs a chase." And so it filled its oceans not just with hunters and warriors, but with drifters, grazers, and armored sages, who watched the tides and took their time. Archelon was one of those sages, It didn't roar or strike or race. It simply glided, a silent witness to the great dramas of the Mesozoic Sea. And though it's been gone for millions of years, its descendants still carry its lesson. Move slowly, stay steady, and let the storm pass. So, next time you see a modern sea turtle gliding effortlessly through clear water, remember that it's following an ancient tradition, a way of life written not in violence but in calm. Its ancestors once shared the seas with monsters, and they survived not by fighting but by enduring. Perhaps that's the oldest wisdom the ocean ever taught. In a world of endless motion, sometimes the best way to survive is simply to keep floating. And if you could hear the voice of the earth whisper to the Archelon one last time, it might say, "You did not need teeth or speed to win. You just needed time, and you had all of it." The oceanic food chain, from phytoplankton to monsters. If you were to look at the Jurassic or Cretaceous ocean from far above, it might appear peaceful sunlight, glittering on the waves, gentle ripples, stretching toward the horizon, clouds drifting lazily across an ancient sky. But beneath that serene surface there existed a world of endless hunger, an invisible engine that drove everything from the tiniest speck of life to the largest beast that ever swam. It was the great food chain of the ancient seas, a living ladder of mouths, teeth, and chants, beginning not with the mighty, but with the microscopic. At its foundation, almost laughably small, lived the phytoplankton, the invisible magicians of the ocean. These were the true architects of survival, tiny, plant-like organisms drifting with the currents, harvesting sunlight and carbon dioxide to build life from thin air. Each one was no larger than a grain of dust, yet collectively they produced most of the oxygen that filled the prehistoric skies. They were, quite literally, the breath of the world. The phytoplankton floated freely in the upper layers of the ocean, in what scientists call the photic zone, the region touched by sunlight. Here they multiplied in staggering numbers, painting the waters green and gold. They didn't fight or flee or bite. Their power lay in abundance. For every glittering predator in the sea, there were trillions of phytoplankton, quietly turning sunlight into sustenance. They were the first link in a cosmic chain of appetite. Where there was phytoplankton, there was soon zooplankton, the microscopic grazers of the sea. Tiny shrimp-like creatures, larvae and protozoa drifted alongside their photosynthetic cousins, devouring them by the billion. This was the ocean's first feast, invisible to the naked eye but essential to everything that would follow. The zooplankton were the couriers of energy, transforming sunlight-powered cells into moving, edible life. And where the zooplankton swam, larger creatures gathered. The next step in the chain belonged to the small filter feeders, organisms that strained these tiny particles from the water. They opened their mouths and let the ocean flow through. A simple yet elegant strategy. Every gulp contained thousands of meals, each one a speck of light turned into matter. The great oceanic cycle had begun in earnest, energy flowing upward, from the smallest drifter to the first hunter. Soon, small fish and crustaceans entered the picture, darting through the water like living sparks. They feasted on plankton clouds, their gills and mouths evolved to sieve the water for nourishment. In the ancient seas, these small fish were everywhere, a glittering mass of silver bodies, flashing in the sunlit shallows and open waters alike. To watch them would have been like watching living light, 1,000 points of movement, turning as one, shimmering, pulsing, alive. These tiny swimmers formed the buffet of the Mesozoic ocean. They were the hinge between worlds, the step where size began to matter, where speed and awareness became tools for survival. Above them loomed the hunters, fast, efficient, and always hungry. From these swarms of small fish rose the predatory fish, streamlined and muscular, designed for pursuit. They hunted with precision, darting after the slower or less cautious members of the school. The chase was quick, the outcome inevitable. Teeth met scales, one heartbeat ended, another continued. In this exchange of life, the ocean maintained its balance, a kind of ruthless harmony where everything existed to feed something else. The pattern repeated itself, scale upon scale. The medium fish devoured the small, and in turn became prey for the larger ones. Every creature was both predator and prey, hunter and hunted, and in this endless exchange, the sea thrived. The food chain was not a straight line, but a web, a shimmering lattice of interactions stretching from the sunlight above to the black depths below. Occasionally, a dead creature would sink to the ocean floor, becoming food for the scavengers below. Crabs, worms, and strange eyeless fish would gather around, breaking down what was once a powerful swimmer into the nutrients that would one day feed the plankton again. Nothing was wasted. In the ancient sea, even death was efficient. But let's drift back upward, toward the light, where the food chain grew fierce and theatrical. Here the medium predators ruled creatures sleek and swift, their bodies designed for motion. They hunted in the upper layers of the ocean, cutting through schools of fish like knives through silk. Their attacks were precise, calculated. They didn't kill for pleasure, they killed because that was the rhythm of survival. From above, the entire scene might have looked almost choreographed. A flash of silver fish scattering in panic. A dark shape cutting through the chaos. The predator strikes. The swarm reforms, and the ocean returns to calm, as if nothing had happened. Beneath the surface, life was a constant pulsing exchange of energy. It was brutal, yes, but also beautiful because every act of consumption kept the circle turning. Higher still in this grand aquatic hierarchy swam the top predators, the monsters of the open ocean. They didn't simply hunt for survival, they ruled. Their presence alone reshaped ecosystems. When they moved through an area, everything smaller adjusted its behavior. Schools dove deeper, plankton shifted with the currents, even scavengers lingered in expectation. The food chain didn't just describe who ate whom, it dictated the very flow of life itself. And yet the miracle of the ocean's food chain wasn't in its violence, but in its balance. Despite the constant feeding frenzy, everything stayed in motion, stable and self-correcting. When small plankton populations grew too large, their predators multiplied in response. When predators became too successful, they starved themselves back into moderation. It was an endless conversation between chaos and order, each keeping the other in check. The beauty of this system lay in its scale. The same pattern that played out between a phytoplankton and a tiny zooplankton also governed the relationship between the great oceanic hunters. Energy flowed upward in steps, and though the creatures grew larger, the principle remained the same: eat, be eaten, and let nothing go to waste. The smallest cell powered the largest beast. The entire ocean was one vast recycling machine, transforming sunlight into muscle and muscle back into sunlight. Think of it like this: every time a giant predator took a bite of its prey, it was really consuming ancient sunlight, stored and passed along through countless bodies. The plankton captured it first, then the small grazers, then the fish, then the hunters. By the time it reached the apex predators, that light was millions of transfers old, a chain of life built on beams from a long-vanished sun. The ocean was, in a strange and literal way, a solar-powered theatre of teeth. Humor helps here, because the truth is a bit terrifying. The ocean's food chain is not a gentle circle, it's more like a conveyor belt that never stops moving. Imagine a microscopic plankton drifting happily, unaware that it's about to become breakfast for a creature 10,000 times larger. That creature, in turn, is already being tracked by something bigger still, which is at that exact moment being eyed by something unimaginably huge. The ocean has no finish line, only layers of appetite. And yet, despite its brutality, there's elegance in this system. Each participant, from the smallest to the largest, has a role that sustains the whole. The plankton feed the grazers feed the hunters, when they die, feed the scavengers, who in turn release nutrients that feed the plankton once more. It's the oldest story on Earth, told in bubbles and blood, repeated endlessly for billions of years. What makes the marine food chain even more fascinating is how quickly it can shift. When plankton blooms exploded, massive clouds of microscopic life spreading for hundreds of miles, it was a feast for everything above. Populations of grazers soared, followed by fish, followed by predators. When those blooms ended, the whole system contracted again, each level thinning until balance returned. The ocean, for all its vastness, breathed like a living organism. Inhale, exhale, feast, famine. Even the deep sea joined this exchange, though it never saw sunlight. When creatures died and sank, Their bodies became what scientists call marine snow, a slow, steady rain of organic particles falling from above. Down in the darkness, entire ecosystems thrived on this endless drizzle of decay. There, the food chain reversed itself, scavengers and decomposers at the top of their world, feeding on the gifts of the dead from above. The surface and the depths were connected in invisible ways. A single plankton cell born in the sunlight might one day become part of a predator, but upon dying, sank to the ocean floor, nourishing creatures that had never known light. From one speck of energy, an entire web of existence unfolded, looping endlessly between life and death. And yet, there was nothing mechanical about it. The ocean's food chain was more than chemistry, it was choreography. Picture it. Clouds of plankton drifting like cosmic dust, small grazers darting through them like sparks, schools of fish flashing silver as they turn, predators slicing through the chaos, and above them massive shadows gliding like gods. It was a dance of light and hunger, a living cosmos contained in water. If the earth could speak, it might have looked upon this balance and said, "This is my greatest trick. I turn sunlight into flesh, and flesh into more life. It's the simplest miracle, and yet it has kept the planet alive for eons." Even humor finds its place here. Imagine a phytoplankton daydreaming, drifting lazily, thinking it has all the time in the world, only to vanish in a gulp, or a small fish darting through a school, thinking it's safe because there are so many of them, unaware that safety in numbers doesn't mean much when a predator can eat numbers by the mouthful. The ocean's rules are simple but merciless. Don't get eaten, and if you must, make sure it's worth the meal. What's most poetic is how the system never stops. Extinctions come, species vanish, oceans shift, but the chain remains. The names of the players change, but their roles endure. The plankton still bloom, the grazers still feed, the hunters still chase, and the scavengers still wait. It's the continuity that matters, the eternal recycling of energy through form. In a way, every bite taken in the sea is an act of participation in something greater. The predator doesn't just eat the prey, it continues the ancient rhythm of the world. Energy flows upward, death feeds life, and the ocean keeps its steady heartbeat. Even we, standing here millions of years later, are part of that story. Every breath we take contains oxygen born from ancient plankton. Every heartbeat is powered by the same sunlight that once fed creatures long turned to stone. The ocean's food chain is not just history, it's inheritance. So when you imagine those ancient seas, don't picture chaos alone. Picture harmony, a brutal, beautiful harmony built on the most primal equation of all. Eat, live, die, repeat. From invisible plankton to towering hunters, every creature played its part in the same timeless symphony. And if you could listen closely beneath the roar of waves and the hiss of bubbles, you might hear the ocean itself whisper its oldest truth. Everything eats, everything is eaten, and through it all, life continues. The war for survival, predators, defenses, and the art of adaptation. If you could descend into the ancient oceans of the Mesozoic era, the Jurassic and Cretaceous seas, you would not find a peaceful world. The sunlight might shimmer on the surface, the water might look blue and calm from above, but beneath those tranquil waves raged an eternal war, not a war of hatred or vengeance, but of necessity, a war written in muscle and motion, in tooth and shell. Every creature from the smallest ammonite to the largest marine reptile was caught in the same endless struggle to eat, to survive, to pass its life to the next generation before becoming someone else's dinner. It was not chaos, but choreography, nature's most intricate dance of hunger and adaptation. Every flipper stroke, every jaw snap, every flick of a tail had meaning. Down here, survival was a profession, and evolution was its teacher. And in this classroom of teeth and scales, the syllabus was simple: adapt or die. The sleek ichthyosaurs were the sprinters of this world, built like dolphins but with the soul of a hunter. Their torpedo-shaped bodies sliced through the water with terrifying precision. They were built for speed, not patience. With enormous eyes that could see through the gloom and tails like living propellers, they hunted with brutal efficiency. You could imagine them in motion, one moment a blur in the distance, the next a streak of silver rushing forward, jaws snapping around a fish before it even knew it was being hunted. Their advantage was velocity, pure, ruthless velocity. In the open ocean, speed meant life. The ichthyosaurs used it to dominate the mid-level predators, picking off fish, cephalopods, and smaller reptiles with surgical accuracy. But speed alone wasn't enough. It required precision, and the ichthyosaurs had that too. Their long snouts were packed with pointed teeth, designed to grip slippery prey. One bite, a shake of the head, and the hunt was over. They didn't waste energy. They couldn't afford to. The ocean favored those who killed cleanly. Far less flashy, but no less dangerous, were the Pliosaurs, those long-necked assassins of the sea. They were the silent watchers, the lurking shadows beneath the waves. Where ichthyosaurs relied on speed, Pliosaurs relied on patience. Picture one gliding slowly through the shallows, its body steady, its neck swaying gently like a serpent in slow motion. The water around it was calm, still, until something moved. A fish, perhaps, darting too close. The Pliosaur's head flicked forward in a blur, jaws snapping shut with a crack that sent vibrations through the water. They were ambushes, living traps designed to wait, not chase. Their long necks gave them reach, allowing them to strike from angles no prey expected. Evolution had taught them restraint. In the ancient sea, that was a rare gift. If the Ichthyosaurs were the jet fighters of the ocean, then the Pliosaurs were the snipers, still precise and lethal. But lurking beyond them all were the mosasaurs, the heavy artillery of the deep. They were the apex predators of their age, the undisputed rulers of the later Cretaceous seas. Where the ichthyosaur was sleek and the plesiosaur graceful, the mosasaur was pure muscle and menace. Long as a bus, armed with jaws that could crush bone, and propelled by a tail built for bursts of terrifying acceleration, the mosasaur didn't chase it overwhelmed. When it struck, it didn't nibble or snap. It obliterated. Its jaws were double-hinged, capable of opening wide enough to swallow prey whole. Its teeth were conical and curved backward, designed not just to pierce but to hold. Once caught, there was no escape, and when it bit with the force of a small car crash. If the ocean had an apex villain, the mosasaur was it, a swimming mountain of hunger and instinct. Smaller creatures had no choice but to adapt. Evolution armed them not with speed or strength but with defense, a quieter, subtler kind of weaponry. Take the ammonites. Those elegant coil-shelled cephalopods drifting through the blue. They couldn't outswim the predators, so they learned to outlast them. Their spiral shells were masterpieces of engineering, divided into gas-filled chambers that kept them buoyant yet strong. When danger loomed, they retreated into their coiled fortress, sealing themselves away behind a hard, unyielding wall. Of course, even the best defenses weren't perfect. Some predators learned to crack those shells open or crush them between their teeth. So the ammonites evolved again, thicker shells, stronger sutures, more complex patterns of armor. Each species was like a new experiment in survival. Some grew spines, others developed intricate ribbing along their shells to deflect bites. Evolution was relentless, and every adaptation was written in calcium and time. Then there were the ancient sharks, like Hybidus, patrolling the reefs and coastlines with the quiet menace of assassins. They were smaller than the great reptiles, but they made up for it in cunning and endurance. Sharks were the opportunists, the patient recyclers of the sea. They didn't need to be the biggest or fastest. They just needed to be there when opportunity struck. Their teeth were the perfect tools for a world of infinite hunger, serrated, replaceable, always sharp. If one broke, another grew in its place. No maintenance, no downtime, just perpetual readiness. Each of these creatures, hunter and hunted alike, was locked in the same ancient arms race. Evolution never stopped tweaking, modifying, and rebalancing. When prey grew faster, predators grew sleeker. When shells thickened, jaws grew stronger. The sea was a laboratory, and every adaptation came at a price. Grow bigger, and you need more food. Grow smaller, and you become easier to catch. Nature balanced the scales with ruthless precision. It's tempting to imagine this world as one of constant bloodshed, but it wasn't always so dramatic. Much of the time it was a tense stillness. The moments between attacks, the slow drift of creatures, avoiding one another, the silence before the next chase. The predators didn't waste energy hunting for sport. They waited for the perfect moment, the slight flicker of a shadow that betrayed vulnerability. For them, timing was survival. In the vastness of the ocean, where visibility was limited and the light dimmed quickly with depth, stealth became one of the most powerful adaptations. Many predators learned to attack from below, rising like shadows through the gloom, using the light above to hide their approach. Others evolved countershading dark backs and light bellies to blend seamlessly into the shimmering layers of blue. Prey animals mirrored these strategies, learning to vanish in plain sight. Some adopted shimmering scales that reflected light in confusing patterns. Others developed translucent bodies that made them nearly invisible. This evolutionary arms race produced not just fearsome killers, but a strange sort of beauty. The ocean became a kaleidoscope of forms, sleek bodies, armored shells, delicate frills, bioluminescent glow. Every adaptation told a story of survival, of a problem solved in the most efficient way possible. Nature, as always, was an artist working in flesh and time. But it wasn't only form that changed behavior. Evolved too, some creatures hunted in packs, coordinating their movements through instinct or simple mimicry. Others developed symbiotic relationships, teaming up for mutual protection or advantage. The oceans were not just filled with predators and prey, they were filled with strategies. Some were violent, others ingenious. Even humor found its place here, if you knew how to look. Imagine an ammonite trying to escape by rapidly jetting away, only to spiral in a clumsy arc because of its shell's design, or a small fish darting for cover under the belly of a much larger predator, using the hunter's shadow as camouflage. Evolution had a sense of irony. Sometimes your best defense was the thing trying to eat you. For every success story, there were countless failures. Not every species could keep up. Those that couldn't adapt fast enough disappeared, leaving only faint impressions in the rock. But their loss was not wasted. Every extinction cleared space for something new. Another creature, another design, another idea. The ocean was never sentimental. It was efficient. Speed, size, shell, stealth. These were the currencies of survival. Some creatures traded in velocity, becoming living torpedoes. Others invested in armor, turning themselves into tanks. A few specialized in camouflage, mastering invisibility. Even the plankton, passive and tiny, evolved in their own quiet way, multiplying faster than anything could consume them. The war for survival had many fronts, and every life form fought it in its own style. You could think of it as a kind of ancient tournament, one with no final winner. Every advantage came with a counter. Every strategy had a weakness. The Ichthyosaurs ruled with speed, but needed constant energy to sustain it. The Pliosaurs struck with precision, but were vulnerable if caught off guard. The mosasaurs crushed everything, but their size made them slow to turn. The ammonites hid in their shells but could not flee. The sharks waited patiently, but patience was no guarantee of a meal. The ocean's law was simple. Perfection was temporary. And yet, through all this brutality, there was a strange, serene balance. Each species in its struggle to survive kept the ecosystem alive. The predators controlled populations, the prey fed the predators. It was a world without mercy, but also without waste. Life continued because life was eaten, and in that consumption the ocean renewed itself. It's easy to laugh, from the comfort of dry land, at the sheer intensity of it all. The ichthyosaurs chasing like missiles, the plesiosaurs lurking like stalkers, the mosasaurs snapping like hydraulic jaws. It sounds almost absurdly cinematic. To the creatures living it, it was simply the way of things. There was no malice, no cruelty, only instinct. The ocean did not care who won, it only cared that the game continued. And so, for millions of years, it did. The ichthyosaurs sprinted, the plesiosaurs ambushed, the mosasaurs devoured, the ammonites spun and hid, and the sharks circled patiently in the shadows. Generation after generation, the same eternal chase played out beneath the waves. Evolution adjusted the details, refined the angles, polished the teeth, but the story remained the same. If you were to hover in that ancient sea and listen, really listen, you might hear the rhythm of it all. The whoosh of a tail slicing through the current, the crack of jaws closing on bone, the hum of water rushing past armor and fin. It was not chaos, it was a symphony of survival. And if the earth could whisper its commentary, it might have said something dry and amused. Adapt or die, my children. It's nothing personal, just physics and hunger. In that endless war, there were no villains and no heroes, only competitors, each trying to outlast the others. The winners lived to see another sunrise. The losers became part of the next meal. Evolution's rules were cruel, perhaps, but they were also fair. The ocean remembers all of it. The chases, the escapes, the clever tricks and the tragic mistakes. It remembers the creatures that learned to swim faster, the ones that grew thicker shells, the ones that learned to vanish in plain sight. It remembers the moment when survival became art, and art painted emotion and muscle in silence and instinct. So if you ever dream of swimming in those ancient waters, remember the rule that governed them all. Everything was hunting, and everything was hunted. It was a world powered by hunger, shaped by adaptation, and refined by the endless need to live one more day. And perhaps if you could hear the ocean whisper from that faraway time, it would tell you with a laugh. Down here, evolution isn't a theory, it's a sport. Fossils and evidence. Stories written in stone by the ancient sea, somewhere in southern Germany. In a quiet limestone quarry near the town of Solnhofen, sunlight glints across pale rock, the kind that holds secrets. At first glance it looks ordinary. Smooth, flat, beige slabs used for tiles or printing stones. But if you look closer, if you lift one of those slabs or brush away a thin layer of dust, you might find an entire world frozen within it. Delicate impressions of wings, ripple marks from waves that vanished 150 million years ago, or the faint outline of a creature that once swam through Jurassic waters. It is there, in places like Solnhofen, that the ancient ocean tells its stories not in words but in stone. Fossils are the ocean's diary. Every skeleton, every shell, every tooth is a page written by time itself, describing who lived, how they moved, what they ate, and sometimes how they died. They are the most honest storytellers, incapable of exaggeration but rich with mystery. The ocean never kept a written record of its dramas, but it left behind evidence, bones scattered like punctuation marks across history's pages. The limestone of Solnhofen is particularly special. It formed in a quiet lagoon, separated from the open sea by reefs and barriers. The water there was calm, shallow, and often lacked oxygen conditions perfect for preserving life, but not for sustaining it. When a creature drifted into that lagoon and sank to the bottom, there were few scavengers to tear it apart, few currents to scatter its remains. Over time, fine layers of silt settled on top, sealing it away like a photograph developing in darkness. And so, when those stones are split open today, we are not just looking at fossils, we are peering through a time window, seeing the last breath of an ancient world. Among the treasures hidden in those rocks are the bones of Ichthyosaurs, the sleek dolphin-like reptiles that once ruled the open ocean. Their fossils tell us more than just their shape. In some, the outlines of their skin and fins are still visible, etched like soft shadows against the stone. These impressions show that their bodies were built for speed, smooth, streamlined, with tails shaped for propulsion. Even more astonishing, some ichthyosaur fossils contain tiny curled skeletons inside them, the remains of unborn young. That simple detail, captured in stone, tells us they gave birth to live offspring in the water, never needing to crawl onto land. It is a single frame from a movie millions of years long, paused forever at the moment of life's continuation. Sometimes the fossils tell darker tales. There are ichthyosaur bones with tooth marks, small crescents carved into ancient bone, hints of attack or scavenging. The teeth that made them may have belonged to other ichthyosaurs, or perhaps to early sharks or predatory fish. These bite marks are not just damage, they are evidence. Each one is a signature of hunger, written in bone instead of ink. Elsewhere in those same sediments lie the elegant remains of Pliosaurs, with their impossibly long necks and paddle-like limbs. Their fossils are often found almost perfectly articulated, each vertebra of that sinuous neck lined up like pearls on a string. It is almost eerie, an animal so fluid in life, preserved in such perfect stillness. Scientists can count the bones, measure the curvature of each joint, and reconstruct how these creatures swam and moved. The flippers, flattened and elongated, suggest a style of swimming that no modern animal quite replicates, something between a penguin's flapping and a sea turtle's glide. Occasionally, a plesiosaur fossil bears a clue to its last meal, fragments of small bones or fish scales trapped near its stomach cavity. These leftovers, preserved for eons, reveal not just what it was, but what it ate. A prehistoric dinner menu written in calcium. In some specimens, even the texture of the stomach contents is fossilized, like a stone cast of digestion. Paleontologists, with magnifying glasses and infinite patience, study these to piece together the chain of life. But the fossils do not always present peaceful endings. Some plesiosaurs are found with broken necks, as though snapped by tremendous force. Others show healed injuries, bones that were fractured and later repaired by the animal's body before death. These are signs of survival and struggle, evidence of a life that was not easy, but persistent. Evolution, it seems, left its fingerprints not only in species but in scars. Scattered among these giants, we find the delicate spirals of ammonites, those coiled mollusks that drifted through the Mesozoic seas. Their fossils are among the most beautiful in the world, shells that shimmer even now, their surfaces glinting with iridescence from ancient nacre. But beyond their beauty, they tell scientific stories of adaptation and survival. The intricate patterns on their shells, called sutures, reveal how strong or flexible their armor was, how they balanced buoyancy and protection. Some ammonite shells are pristine, perfect spirals that look as though they could still house a living creature. Others are shattered, crushed by the bite of some long-vanished predator. These broken shells are evidence of encounters, of ammonites hunted, of jaws snapping through their defenses. Paleontologists have found clusters of ammonite shells with consistent bite marks, each one positioned near the same point on the spiral. It suggests intelligence in their hunters, creatures that learned exactly where to strike for the kill. A fossilized ammonite, cracked in the same way as dozens of others, becomes more than a shell. It becomes a crime scene preserved forever. And then there are fossils that capture moments so fleeting, they seem impossible. A fish, mid-swallow, frozen in the act of eating another fish. A squid-like creature clutching its prey, both buried in an instant. Even an ammonite shell pierced cleanly through, as though by a spear the predator's tooth still lodged inside. These are the ancient equivalents of action shots, captured not by cameras but by catastrophe. A sudden landslide, a collapse of sediment, a quiet lagoon sealing them away in darkness, and time took care of the rest. Every fossil is a witness. Together they build a courtroom of evidence that allows scientists to reconstruct the ocean's history. Bone density reveals how deep a creature could dive. Tooth shape hints at diet and hunting style. Wear patterns show whether a predator tore its food or swallowed it whole. The orientation of skeletons in the sediment even reveals the direction of ancient currents. It's detective work on a planetary scale, each discovery a clue in a case millions of years old. Some fossils even preserve the soft parts, the rarest of all gifts from time. In certain layers of limestone, paleontologists have uncovered outlines of fins, eyes, and even internal organs, transformed into minerals, yet still recognizable. These whisper of the animal's colors, textures, and motions. They are the ocean's last portraits of its children, sketched in sediment and sealed beneath the weight of eternity. But perhaps the most fascinating fossils are the imperfect ones, the partial skeletons, the scattered bones, the ones that force imagination to fill in the blanks. A single tooth can redefine an entire species. A bone fragment can rewrite our understanding of an ecosystem. Science is built as much on what's missing as on what's found. The gaps between fossils are as intriguing as the fossils themselves, spaces where we glimpse the creative chaos of evolution. In other parts of the world, fossils tell the same story in different dialects. Along the cliffs of England, the skeletons of marine reptiles rest in layers of shale, their bones blackened by minerals. In the chalk beds of Kansas, entire skeletons of sea creatures lie where ancient seabeds once stretched. In each case, the message is the same. The ocean remembers everything. It has kept a perfect archive, buried deep but not lost. If you run your hand across a fossil ammonite, You're touching the remains of an animal that once floated in sunlight, filtering water and chasing plankton, unaware that it would one day be a museum exhibit. A fossil fish once swam through coral gardens, long turned to dust. A reptile skeleton once soared through water that covered continents. And yet, through a strange alchemy of pressure, minerals, and time, their story is endured. Humour, of course, finds its way even into this solemn record. Fossils occasionally surprise the scientists who find them: a plesiosaur tangled in a knot, a fish with its own tail in its mouth, an ammonite preserved upside down in what seems like an undignified pose. It's as though nature left a few jokes scattered through the strata, small reminders that even extinction had its moments of absurdity. Still, behind every discovery lies wonder. How did such fragile things survive for so long? How can something as delicate as a fish's fin or a reptile's rib remain intact after 150 million years? The answer lies in chemistry and chance. When a creature died and sank to the seafloor, minerals seeped into its bones, replacing organic material atom by atom. Over millennia, the living became stone, and stone became story. The process was slow, quiet, and miraculous. Every fossil bed, whether in Germany, England, or North America, is like a time capsule, each layer a page in a cosmic book. The deeper you dig, the older the story becomes. You can trace evolution in the strata, from the rise of early marine reptiles to the diversification of ammonites, from the flourishing of coral reefs to the creeping shadow of extinction. The Earth didn't write these stories for us, but it left them where we could find them if we learned to read the language of stone. And that language is eloquent. A spiral shell says, "I floated once, I lived lightly, I hid when I could." A tooth says, "I hunted, I tore, I survived for a time." A broken bone says, "Something found me before you did." Together, they form a chorus of voices rising from the depths of history, not mournful, but proud. If the Earth could speak through these fossils, it might say something like, "See, I remember, I keep everything you leave behind." The rocks are the archives of memory, the sea's own library, every fossil a paragraph in an endless autobiography. In the Solnhofen limestone, the story is told in exquisite detail. A ripple in the sediment shows where water once flowed. A line of bubbles marks where a creature struggled. The faint outline of a fin records a motion so swift it lasted less than a second. Time has flattened it all into silence, yet somehow the emotion remains. You can almost feel the movement, the panic, the stillness that followed. Fossils don't lie, but they do whisper. They tell us that life was dynamic, that the ancient oceans were full of conflict and creativity, of survival and loss. They reveal not just anatomy, but behavior: who chased whom, who hid, who adapted, who failed. They are the physical evidence of evolution's endless experiment. And if you listen carefully, there's humor in their patience. Imagine the ammonite thinking, as it sank into the sediment, "Well, this is a bit inconvenient." Or the ichthyosaur, unaware that its final resting place would one day sit beneath a museum's spotlight. Labeled and admired, nature, it seems, loves irony almost as much as beauty. So the next time you see a fossil, whether it's a delicate ammonite spiral or the jawbone of a sea monster, remember that it's more than a relic. It's a page from an ancient ocean story, a moment of life that refused to be forgotten. The sea may erase footprints in seconds, but in the right conditions, it keeps its bones forever. If you could hold a piece of Solnhofen limestone in your hands, feel the faint ridges of a creature's form pressed into stone, you'd be holding more than rock. You'd be holding a moment, one heartbeat from a world long gone, perfectly preserved by time's slow mercy. And perhaps the Earth would whisper, softly amused, "You see, my oceans remember everything. You don't need to dig deeper. I've already told you the story. Lessons from the Jurassic Ocean, survival and diversity." If you could stand at the edge of the Jurassic Ocean, feel the salt wind, hear the hiss of the waves, and watch the endless procession of fins and shadows, you might think you were looking at chaos. Creatures hunted and hid, shells cracked and healed, waves rolled in and out as they always have. But beneath the drama of tooth and tail, there was something deeper happening. A conversation between life and time, a slow education in how to survive a changing world. The Jurassic Ocean wasn't just a place of danger, it was a teacher, and the lessons it taught still echo through every current and coral reef today. The first lesson, perhaps the oldest and most important, is this: adaptation is everything. The creatures of that era didn't survive because they were the strongest or the largest. They survived because they changed when the world demanded it. The ocean was an ever-shifting puzzle of temperature, chemistry, and geography, and life had to keep rearranging itself to fit. When the continents of Pangaea began to drift apart, the currents changed, the tides changed, and so did the living things. Fish developed new ways to swim, marine reptiles evolved new shapes, and hunting strategies, microscopic plankton, learned to capture sunlight more efficiently. Every adaptation was a tiny, creative response to change. In this vast, watery classroom, the rules were clear. No one gets to stay the same. The ammonites learned to coil their shells in tighter spirals to survive pressure and predators. The ichthyosaurs refined their sleek forms for speed and endurance. Even the plankton diversified, evolving into countless shapes and colors, invisible architects of the ocean's balance. Evolution was not a luxury, it was the price of admission. But the beauty of adaptation is that it doesn't just ensure survival, it creates diversity. When life tries new solutions to the same problem, the result is a gallery of possibilities. Some creatures evolved armor, others wings, others speed, others cunning. The Jurassic Sea was a living experiment in creativity. Every reef, every lagoon, every dark trench had its own ecosystem, filled with its own actors and its own dramas. Diversity wasn't random, it was the ocean's way of building resilience. When one species faltered, another stepped in. When the environment shifted, something new evolved to fill the gap. It was nature's insurance policy. If the Earth could have spoken then, perhaps it would have said, "Variety is my shield, I survive through change," and indeed it did. The Jurassic Ocean flourished not because it was calm or kind, but because it was full of difference. Millions of strategies for life, all coexisting, all feeding, breeding, and balancing one another in a grand, self-sustaining design. That leads to the second great lesson: balance sustains everything. The food web of the Jurassic Ocean was not a simple chain of eaters and eaten. It was a network, a web of energy, that moved in circles rather than lines. The smallest plankton fed the smallest grazers, who fed the larger fish, who fed the great marine reptiles, whose remains eventually sank to the ocean floor to nourish the smallest organisms once more. Nothing was wasted. Every act of consumption was an act of renewal. It's easy to look at that system and see only brutality, but in truth, it was harmony. Each species knew by instinct or design its place in the rhythm. The predators prevented overpopulation, the prey sustained the hunters, the scavengers recycled what was left. In its own strange way, it was fair. The ocean wasn't cruel, it was efficient. Its balance was not moral, but mathematical. Modern scientists might describe this as ecological equilibrium, but perhaps a simpler phrase is better. The ocean knew how to share. When one population grew too large, the web adjusted. When a predator disappeared, another evolved to take its place. Life filled every gap, like water seeping into cracks in stone. It was a system of exquisite give and take, where stability was achieved through constant motion. Of course, balance is never permanent. It's more like a dance than a destination. Sometimes the ocean's rhythm faltered. Volcanic eruptions darkened the skies. Sea levels rose and fell. Currents shifted. Each change sent ripples through the web, testing the resilience of its design. And here lies the ocean's third great lesson. Disaster is part of the story. The Jurassic Ocean was not exempt from catastrophe. There were extinction pulses, smaller than the great mass extinctions, but devastating all the same. Temperature swings, shifts in carbon dioxide, even local oxygen crashes all took their toll. Entire families of species vanished, leaving room for others to rise. It was tragic, yes, but also creative. Each collapse cleared the slate for evolution to try again. The ocean never stopped, it simply rewrote its story. And then, much later, millions of years after the Jurassic gave way to the Cretaceous, the greatest catastrophe of all arrived. A rock from space, 6 miles wide, struck the Earth with the force of 1 billion atomic bombs. In a matter of hours, the world that had been familiar for 80 million years changed forever. The sunlight dimmed, the temperature plunged, and the food web, so delicately balanced, fell apart. The oceans, once teeming with life, turned silent. The great marine reptiles, the ammonites, and countless others vanished. It is here that the final lesson emerges. Nothing lasts forever, and that is the secret to life's endurance. Every ecosystem, no matter how vast or ancient, will one day fall, but extinction is not the end of life. It is the reset button. After every collapse, the survivors rebuild, reshaping the world in new forms. The Jurassic Ocean may have vanished, but its lessons did not. Its descendants still swim among us, in the fish, the whales, the turtles, the cephalopods. The strategies of that ancient age, the adaptations, the balance, the resilience, still define the living ocean today. In that sense, the Jurassic never truly ended. It evolved. There is something quietly humorous about it all. Imagine the ammonites, spiraled and armored, believing their shells made them invincible, only to find themselves erased by forces beyond imagination. Or the mighty marine reptiles, perfected by evolution over millions of years, undone not by a rival predator, but by a space rock. Nature, it seems, has a dark sense of irony. Just when a species masters its environment, the environment changes the rules. But perhaps that is the point. The lesson of the Jurassic Ocean is not that stability is possible, it's that change is survivable. The sea has always been a laboratory for adaptation, a testing ground for life's flexibility. Those who cling to constancy are swept away. Those who adapt, those who innovate, diversify, and move with the current become the ancestors of everything that follows. The modern ocean still runs on the same ancient logic. Phytoplankton continue to feed the world. Coral reefs still create shelter and balance. Predators still shape the abundance of life around them. The food webs have evolved, but the principles remain unchanged. Life's resilience depends on connection, on the invisible threads that tie one creature's survival to another's. Even the great catastrophes have a strange generosity to them. They prune the tree of life, yes, but they also give it room to grow in new directions. Without extinction, there would be no innovation. Without loss, no transformation. The Earth, for all its violence, is also endlessly creative. You could think of the Jurassic Ocean as a rehearsal for everything that came after, a cosmic prototype. It was the testing ground for ideas that still echo in today's seas: streamlined hunters, complex food webs, symbiotic partnerships, and the delicate balance between competition and coexistence. The same pressures that shaped Ichthyosaurs and ammonites are shaping dolphins and jellyfish now. The tools have changed, but the game remains the same. It's humbling to realize that we owe our existence to those ancient lessons. Every breath of oxygen we take comes from descendants of Jurassic plankton. Every ecosystem on Earth, from rainforest to coral reefs, is built on the same foundation of balance and adaptation that evolved in those primordial waters. The ocean taught life how to survive, and life remembered. And if you look at the bigger picture, there's something deeply philosophical in that. The story of the Jurassic Ocean isn't about domination or permanence. It's about continuity. Each species, each era is a chapter in a story that never ends. The players change, but the plot remains. Life meets challenge, adapts and continues. Even the asteroid, that infamous punctuation mark in Earth's history, was just another turning page. Perhaps that's why the fossil record feels less like a graveyard and more like a symphony score. Every extinction, every adaptation, every strange new form of life was a note in a melody that's still being played. The Jurassic Ocean was one movement in that symphony, full of crescendos, silences and improvisations, and though its players are long gone, their music still reverberates in the heartbeat of every living thing. Humor, again, softens the lesson. One can imagine the Earth watching all of this, the rise and fall of its creatures with the weary affection of a parent. It might sigh, they've discovered speed again. Let's see how long that lasts. Or, when a new predator evolves with sharper teeth. Lovely, now the prey will learn to hide better. It's a conversation without end, the same joke told a million different ways, and perhaps that's the quiet comfort, hidden in all this grand history, that even in extinction, even in upheaval, life never gives up. It changes costumes, changes shapes, but the play continues. The Jurassic Ocean may have closed its curtains, but its lessons flow in every tide that touches our shores today. So what can we take from that ancient sea? Maybe this: survival is not about strength, but about imagination. The ocean's diversity, its countless solutions to the problem of living, was its greatest triumph. Its balance, fragile yet persistent, was its masterpiece, and its willingness to begin again after disaster, that was its wisdom. If the Earth could whisper one last message from those Jurassic depths, perhaps it would be this: change is not your enemy, it's my language. Learn to speak it, and you'll always belong here. Because in the end, the ocean has always known the truth that all of life must eventually understand. The waves will rise, the continents will drift, the stars will fall, but as long as something adapts, something endures, the sea will keep teaching, and life will keep learning. And somewhere, deep beneath the modern waves, the echoes of the Jurassic still shimmer, whispering the same eternal lesson. Soft and amused, like an old friend, stay balanced, stay curious, and when the next change comes, swim with it. And now, as we drift gently back from the depths of time, the ripples of the Jurassic Ocean begin to fade, like the last notes of a song dissolving into silence. We have travelled through its vastness, from the endless blue of Panthalassa to the glittering shallows of Tethys, through warm, golden waters that shimmered with life, through a realm ruled by creatures both magnificent and strange. It was a world of power and grace, of danger and discovery, a world that once belonged to the sea and to the endless imagination of the Earth itself. The Jurassic Ocean was not merely a place, it was an era, a golden age beneath the waves. It taught life how to adapt, how to balance, how to thrive in motion. Beneath its calm surfaces, evolution sculpted masterpieces of form and purpose. Every creature, from the smallest drifting plankton to the titans of the deep, carried a story of transformation, a testament to the quiet intelligence of nature. It was a kingdom without kings, where survival was the only crown, and the rhythm of existence moved with the tides. The waters of that age were warm and alive, pulsing with energy and beauty. It was a time when the seas ruled the world, when the continents were still dreaming of separation, and when life found its richest expression not on land, but in the blue beneath. The Jurassic was Earth's great underwater symphony, full of motion, mystery, and harmony. And though its players have long vanished, the melody continues, carried in every current, every scale, every breath of ocean air we know today. Now, as we close our eyes and let that ancient sea recede into memory, imagine its surface glowing under a pale moon. The waves whisper of creatures that no longer swim, of stars reflected in water that once touched their light, millions of years ago. Somewhere in that dreamlike stillness, the Earth herself hums softly. The same tune she has always sung, the music of life, changing and enduring, forever flowing like the sea. So, take a slow breath. Let the ocean's rhythm calm your mind. The Jurassic is far away, yet still close enough to feel in the pulse of the tides, in the hush of the night, in the vastness of your own imagination. If you've enjoyed wandering through this ancient world, share your thoughts, let your curiosity drift, and carry with you a little of its wonder. For the ocean remembers, even when we sleep. Good night, and may your dreams swim gently through the warm golden waters of the Jurassic Ocean, where time slows, the waves shimmer, and the deep still whispers its secrets beneath the stars.